Morning, everyone. Good morning, good morning, good morning, good morning. Have a nice day for all of you people. Okay, so I hope you have utilized yesterday very well. So I hope you people have gone through the notes. Yeah. So news says courier services has opened. Yes, it may. If it has opened, then within a short span, the AH team will be able to send you the practice questions and all those things. So don't worry about that. Okay, so let's start our session. Yes. Yesterday we have been discussed about means a day before yesterday. So day before yesterday we have been discussed about a direct shear test. So let me go through the once again. So direct shear test, and at starting I discussed about the dryness conditions, and I told you if the rate of loading is slow, then it is going to be a drained condition. If the rate of loading is quick, water won't dissipate, then it's going to be undrained condition. So generally for for gravels and sands, granite soils, we go for drained, and in the case of clays, we go for undrained. But in clays, if the rate of loading is going to be very slow, then the drained test also can be conducted. So from this, I said you, in undrained condition, the stability should check immediately after the condition, immediately after the construction. If pore water pressure is going to be positive, so I have written over here. If pore water pressure is positive, like foundation on clays, earth films, short-term stability analysis, we go for total stress. And if pore water pressure is negative, means by means of excavations, long-term stability analysis. And then I discussed about so what happens when Mohs circle touches to the failure envelope, and then I discussed about when failure envelope touches to the Mohs circle, what is the angle made by the failure plane? What is the angle made by the failure plane? Which is going to be 45 plus 5 by 2, where alpha F is angle made by failure plane. Alpha means any plane, and if it is a failure plane, then alpha becomes alpha F. And then we discussed about does the failure stress is exactly at maximum shear stress? No, it need not be. So the failure shear stress can be less than or equals to tau maximum. And then we discussed about this plastic equilibrium equation by taking from the figure itself. So sigma 1 is equals to sigma 3 tan square alpha f plus 2 c tan alpha f. And now see, these are very, very important today's class, because I'm going to use numericals today. And so we are going to solve numericals. So now, if I say cohesionless soils, then what happens? If I say cohesionless soils, C is equals to 0 and phi is equals to sine inverse of major principal stress minus minor principal stress by major principal stress plus minor principal stress. So you please keep this in your mind that when C0, phi is sine inverse of major minus minor by major plus minor. And if phi is equals to 0, then C is equals to simply tau maximum. If you see the Mohs circle over here, phi 0, C is nothing but tau maximum, which is nothing but radius, sigma 1 minus sigma 3 by 2. And in the case of the C and phi both are there, you cannot use this logics. You have to use the two data to obtain C and phi. And then we have done some question. So I have given you one question also. Yes. So this is the question I have given you. And in this question, so I mentioned you if there is a stresses acting on the soil element, how to find out the normal stress and shear stress. And if it is a soil is a pure sand, how to find out the alpha F. So all these things have been discussed. And then we discussed about the direct shear test. So in the case of the direct shear test, the biggest disadvantage is failure plane is predetermined. So predetermined as horizontal. And moreover, here there is no control over the drainage. As there is no control over the drainage, this test is suitable only for drained conditions. See, drained conditions means here C and phi are going to be C dash, phi dash. C comma phi means C dash, phi dash. And not only that, direct shear test is suitable for only free drain soils, and it can be suitable for the fissured clays or fissured cracks. So now that's about the direct shear test. In the case of direct shear test, we are going to do the failure envelope directly, and we find out the C comma phi. Now there comes the results I have mentioned you. The point is loose sand, shear becomes dense sand, and positive pore water pressure is going to be increases. Compression volume is going to be decreases. In loose sand, volume decreases. In loose sand, excess pore water pressure increases. In loose sand, directly stress versus strain. And in the case of loose sand, volume decreases, void ratio decreases up to the critical. And in the case of dense sand, first initially it undergoes compression, which means initially some pore water pressure increases, volume decreases, and later on, due to breaking of interlocking between the particles, soil starts to dilate. Dilate means increase in volume. So in the case of the dense sand, first volume decreases and then increases. First pore water pressure increases, and due to increase in volume, positive pore water pressure becomes negative. And again, so you can see the peak and immediately falling down due to breaking down of the interlocking, and this strength is nothing but due to interlocking. And same in the case of the void ratio curves also. I have explained these things clearly. Now let's start the very, very important test, triaxial shear test. I hope the people have been joined. Yes, this chapter will be completed mostly today. I'm drinking a cup of coffee. Yeah, most probably we are going to complete the chapter today. Now, means I'm just looking over the attendees so that we can. Now, see, I just take this triaxial shear diagram so that we don't need to. Okay. So now, let's see. Okay, fine. Now, let's come to the triaxial shear test. So instead of wasting our time to draw this figure, I have taken a clear picture. So I have made it already. Now, you please look over this figure. See, I hope everybody is able to see this figure. So now, whatever the outer face, this is nothing but the triaxial cell. This is nothing but the triaxial cell. So if you observe, this is nothing but the triaxial cell. And a triaxial cell is a circular cylinder which is made up of a glass, circular in plan, cylinder in the section, circular in plan and cylinder in the section. So which is made up of a glass. If you observe, yes. Now, if you see, this is the actual triaxial shear test figure. This is the actual triaxial figure. So if you observe, you see, this is nothing but So this is nothing but the triaxial test apparatus, whatever I am showing you here. So you can observe this is nothing but a glass membrane or not, which is going to be circular in plan and cylinder. So now what I am going to do is I am going to take the same one. So if you observe, this is going to be the triaxial. Yes. So now let's see, in the case of the triaxial, now if you observe, whatever this is nothing but the soil mass, I'm going to take inside of this one as a soil mass. This is a soil element. This is a soil element, and this soil element is going to be present between, you see, this is one porous stone, and this is going to be one more porous stone. If you observe over here, this soil element has a above one porous stone and below has a one porous stone. So now, and one more thing, this soil element is going to be covered with one green line I am showing you over here, and that green line is known as impervious membrane, which is nothing but the rubber membrane. So whatever I am showing you here as a triaxial sample, and inside this is a soil sample, and above and below of the soil there are some porous stones, which means the porous stones means if you want to allow the drainage, then you can allow the drainage. Now you see, whatever this valve I am representing now, whatever this valve I am representing now, this valve is going to be control the drainage. If I close this valve, now you please observe. If I close this valve, through this porous stone, water won't come out. Because if I close the valve, water won't come out. If water won't come out, means if water will not dissipate, can I say such a type of condition as undrained condition? You know the meaning of undrained. If the water won't dissipate, then such type of condition is known as undrained condition. And if I open the valve, then only the water will be goes out. Then such a type of condition is known as a drained condition. So now let's see, before going to this triaxial test, this test consists of two stages. This test consists of two stages. Stage 1, consolidation stage. Stage 2, shearing stage. Stage 1, consolidation stage. Stage 2, shearing stage. Now, so in the case of the consolidation stage, see, so far we have been known that. Now everybody have a look. If this is a soil element, first of all we are going to apply load, and then soil will undergo compression known as consolidation, and then the soil will undergo shearing due to normal stress, consolidation, due to shearing stress, shearing. So now what we are going to do in this test, sir? Sir, in this test, you are going to see the advantages are, number 1, if you observe over here what I am representing, pore pressure are piezometric. So you can find out the pore water pressure inside of the soil mass. Okay, number 1. Number 2, due to this wall, drainage conditions can be controlled. dryness conditions can be controlled by operating valve. Which means you can do the undrained test, you can do the drained test also. So next, pore pressure measurement. Pore pressure measurement is possible. And in the case of the direct shear test, one more disadvantage is a failure plane was predetermined as horizontal. And in the case of the triaxial, this soil can fail anywhere. Failure plane is not predetermined. It will be weakest plane. So whatever the failure plane that we are going to say, that will be a weakest plane. So now what we do, sir? Sir, in this cell, what we are going to do is, by using the cell pressure, we are going to insert a water. You are going to insert the water. You see whatever I am representing over here, this is nothing but the water at a constant pressure. So you please look over here. See, due to this whatever the pipe I am projecting over here, so due to this pipe, means by using this pipe, I am going to allow some water. Whatever, this is nothing but the water. And now once the cell is going to be filled with the water, you see, as this is a rubber membrane, the green line I am showing you, and I said to you this is impervious, so this water won't enter into the soil mass. Don't think this water will enter into the soil mass. But what happens over here is, if this is an element, so now the entire soil mass, this is a cell, right? Inside of the cell I am filling with whom? Water. So in all the directions, this water will apply some pressure. You know that this water will definitely apply some pressure or not? In all the directions, the water will apply some pressure, and that pressure is known as confining pressure. So now, let's see. So this is soil mass, and now if you observe, due to water, this is a soil, due to water, in all the directions, you can see a pressure. In all the directions, you can see a pressure, and you are going to make it as a constant pressure. So first of all, you will observe. So by filling the triaxial cell with water, it applies a pressure known as a cell pressure, and that cell pressure is going to be acting on the soil mass in all the directions. So this cell pressure, I am going to represent that pressure as a sigma C. Sigma C, and he is going to be also sigma C. So first, point 1, due to water present in a triaxial cell, it applies a confining pressure on soil. Now you see this sigma C can be called as cell pressure or confining pressure. cell pressure or confining pressure. So now everybody have a look. Let's go to the figure again. See, this is a soil element, right? This is a soil element, and this soil element is going to be undergoes some pressure acting on the soil. Sorry, some pressure acting over here. This is known as sigma c. For example, if it is a saturated soil mass, you know that. Again, remember the consolidation topic. Everywhere, when an external pressure of sigma c on a fully saturated soil, who will be take the external pressure? Immediately that will be developed as excess pore water pressure. Repeating point again, when an external pressure of sigma c is developed in the soil mass, that sigma c will be developed as a excess pore water pressure. Yes, you know that. Yes or no? Now let's go to the figure. See what I am providing. This is nothing but a drainage valve or not? This is nothing but the drainage valve. Arre Baba, if I open this valve, what happens? If I open this valve, you please look over here. This drainage valve is there. And if I open the valve, see in this soil mass, the excess pore water pressure would be there or not? So now, whatever the pressure, see there is a water pressure in all the directions. Water pressure in all the directions. See, this is a soil mass. Inside of whatever the arrow marks I am representing is a excess water pressure. Now, if I open the drainage valve, see this drainage valve is nothing but a tap. If you open the drainage, water will dissipate. When the water dissipates, is it a drained or undrained? Drained. If the water dissipates, definitely consolidation is going to be happen or not? Yes, definitely consolidation is going to be happen. So now if I open the drainage during the first stage, if I open the drainage, then the water will be dissipate, then the consolidation is going to be happen. And sir, if you don't open the drainage valve, then what happens, sir? If you don't open the drainage, no pore water will dissipate, then it is known as undrained. When I say undrained over here, that is known as unconsolidated. Okay, sir. Fine, sir. You said that. Okay, this is a soil mass and it is going to be subjected to a pressure of sigma c. And if I open that tap, then the consolidation happen, means drainage happen. If I don't open the tap, then there is no dissipation, no consolidation. Then what about the shearing, sir? You see this one? What about the shearing, sir? Sir, can you please tell me what is the shear stress? I hope you remember the shear stress is nothing but sigma 1 minus sigma 3 by 2 sine 2 alpha. Yes, sine 2 alpha. You please look over on this element. Now, please tell me on this element, sigma 1. What is sigma 1 over here? Sigma c. And what is sigma 3 over here? Sigma 3. Sigma 3. Major principal stress is a sigma c. Minor principal stress is also going to be sigma c. So with the confining pressure, major principal stress is going to be same. Minor principal stress is going to be same. Yes. When the major and minor both are same, then what is our tau? Tau is equals to 0. So now, my dear students, understand it clearly. When you are applying the water inside of the triaxial cell, this water will exert a pressure known as a confining pressure, and that is same in all the directions. So in this case, sigma 1 is equals to sigma c, sigma 3 is also going to be sigma c. So as a sigma 1 and sigma 3 both are same, then the shear stress is equals to 0. Shear stress is equals to 0. So now can I say, so you know that tau is nothing but sigma 1 minus sigma 3 by 2 sine 2 alpha. So from this what we got to know here is, From this, what we got to know over here is, Are Baba, as due to cell pressure, as everywhere, see, does this just looks like a hydrostatic condition? Yes or no? Baba, water pressure is nothing but hydrostatic loading or not? So hydrostatic loading means the pressure is same in all the directions. Keep that in your mind again and again and again. This is a hydrostatic loading because this is a water pressure. Now, this confining pressure, due to this confining pressure, what is going to be happen? Consolidation is going to be happen, but shear stress is not going to be happen. So, as cell pressure is same in all directions, shear stress is 0. Why, sir? Cell pressure same means major principal stress and minor principal stress both are same. Then the shear stress is equals to 0. If the shear stress is going to be 0, then what we are going to do is, so no shearing will occur. Look, due to cell pressure, there is no shearing at all. Only consolidation is going to be happen. Now what I do is, sir, in order to occur the failure, there must be a shear stress. So now what I am going to do here is, to shear the soil, I hope everybody will be seeing now. This is now piston, right? Due to shear the soil mass, I have to increase the stress. Now keep one thing in your mind. You know that when sigma greater than sigma 3, then only the shear stress is going to be greater than 0. Yes or no? So you know that when the sigma 1 is more than sigma 3, then only the shear stress is going to be greater than 0. So now what I am going to do is, to shear the soil mass, I am going to apply an additional load of, let's say, P. Additional load of, let's say, P through this piston. And due to this piston, definitely on the soil mass, some more pressure would be exerted or not. Due to this piston, due to this additional load P, some more pressure will be acting on the soil mass or not. Now, what we are going to do here is, at first, triaxial means in all the directions, we apply a water pressure. Now to shear the soil mass, an additional load is applied through piston, and it is known as additional pressure or deviatoric stress. Let's represent with a sigma d. So now what I am going to do is, you please look over them through piston. I am going to apply an additional load of P, and due to that there must be some additional pressure on that. Now you see in which direction? In axial direction only. So now I say, you know, this is nothing but the sigma c. Now due to the additional load, whatever the pressure is nothing but the sigma d. And in the vertical direction, in both directions, you can observe here also there is going to be sigma d. So now can you please tell me what is the major principal stress over here? So now you observe in the vertical direction, the pressure is going to be sigma d plus sigma c. And this is going to be sigma c plus sigma d. Yes. And what is the minor principal stress? Sigma 3 is equals to sigma c. And what is the major principal stress? Sigma c plus sigma d. Now you observe clearly the major principal stress is there and minor principal stress is there, then the shear stress is going to be starts to act or not. Now you see, this is any plane, and on this plane definitely there is a normal stress, and now due to this definitely there is a shear stress. So to shear the soil mass, an additional load is applied through piston, and it is known and it is known and sorry, yes, it is known as additional pressure. So now due to that additional pressure, now the shear stress is going to be acting or not, because what is the sigma 3 over here? Sigma 3 means sigma c. And what is sigma 1 over here? Sigma c plus sigma d. Now if you substitute over here, then the shear stress is going to be like sigma 1 minus sigma 3, sigma d by 2 sine 2 alpha, and this is nothing but the alpha, right? Now as the sigma d increases, the shear stress is going to be increases, and at certain point of time, whenever the shear stress becomes failure shear stress, then sigma d becomes sigma df, and whatever this is nothing but the shear strength. So now what I am going to write is, note down the deviatric stress at which failure or shear failure occurs as sigma d of f. Sigma d of f. So you please observe. First of all, I am taking see the sigma deviatric stress. This is known as sigma d. First of all, I am taking that due to water present in the triaxial cell, it applies a confining pressure sigma c, and as cell pressure is same in all directions, no shearing will occur. I am giving you pure explanation over here. And then as there is no shearing, I cannot find out the shear strength. So in order to undergo the shearing, an additional load is applied through piston, and that pressure is known as sigma d. And now as the sigma d is going to be increases and increases, then the tau becomes tau f. So now the same element, this time what is this? Sigma 1. What about here? Sigma 3. And now, you know, this is a failure plane, and whatever the normal stress and the shear stress at failure. Normal stress and shear stress at failure, where sigma 1 is nothing but sigma c plus sigma d at failure, and where sigma 3 is going to be sigma c. Does this element is exactly looks like the same element we have been discussed so far, haven't we? And whatever this failure stress alpha f, and this is nothing but the shear strength, and you know that at failure, whatever the failure shear stress is nothing but the shear strength. So yes, this test, see, the soil can be saturated or dry state also. In the case of dry state, we don't need to worry. But in the case of the soil is saturated, see, this is normally, it can be dry or saturated. So wait for that. I'll be discussing about the drainage conditions also. Don't worry about that. Okay. Now, you please observe. See, I have got these values. What I'm going to do is, yes. So now, once we got these values, conduct similarly on 2 or 3 identical specimens, yet by increasing cell pressure, See, conduct similarly on 2 or 3 identical specimens by increasing the cell pressure. You see, in stage 1, you observe now, this shearing stage is going to be happen due to whom? Sigma D. So who is responsible for the shearing? The shearing is going to be happen due to sigma D. So consolidation stage is going to be sigma C and shearing stage is going to be sigma D. So now, if you see, in stage 1, we apply sigma C as an all-round pressure. And in stage 2, we apply sigma D. And once we know the sigma C and sigma D, can't we find out the sigma 3? What is sigma 3? Sigma C. Can't we find out the sigma 1? Yes. Can't we find out the sigma 1? Yes. And now you know that during the test, by playing with the drainage valve, if you don't open that test, or if you don't open the drainage valve, definitely pore water pressure is going to be developed. Yes. Whatever the pore water pressure that can be developed inside of the soil mass. See, if I open the drainage valve, then pore water will disappear and excess pressure will be 0. But if I don't open the drainage valve, then the excess pressure will be there. How much excess pressure is going to be measured by means of the piezometer. So pore water pressure, sigma 3, sigma 1 and pore water pressure. Yes or no? So similarly, you apply sigma 3, sigma D, sigma 3, sigma 1. Similarly, you can get down the details. I hope you understood what I am doing over here. I am doing just 2 stages. Sir, initially soil contains water, sir. Yes, sir. Okay. Now, once we know the sigma 3 and sigma 1, finally what we are going to do is, if you observe, yeah, now you have sigma and you have a shear stress. Now, once I get the sigma 3 and sigma 1, can't I draw the more circles? Yes. What I am going to draw here is more circles. Look, I am drawing a different type of more circles over here. Now, observe. Yes. See, this is for the first data. This is for the first data, first. And this is for the second data, second. And this is for the third data, third. See, what we are going to do is, for every test, we increase the cell pressure. By increasing the cell pressure means the sigma 3 is going to be increases or not. Now, when the cell pressure increases, then the deviatoric stress is also going to be increases. So now if you draw the more circles for our different specimens, now you know that the failure envelope touches the more circle at one point. You please go back. You please look over here. What is the failure envelope over here? failure envelope acts like a tangent to the Mohr circle or not? Yes. Failure envelope acts like Mohr circle. So by using that, now, what I'm going to do is I'll try a best possible line that can touches the points. So this is the best fitting line. Now, this is the best fitting line. This is the best fitted line. And now it will touch us to the Mohr circle at one point. Yes or no? And this is known as failure envelope. This is known as failure envelope. And what are the intercept it made is nothing but C, and the angle is going to be phi. So finally, what we need to find out is C comma phi only, right? Finally, what we want to find out is nothing but C comma phi. So that C comma phi is nothing but the shear strength parameters. So now let me repeat this once again. Now the conclusions I am going to say here, this is a soil mass. At first you apply water. Due to water in all the directions, there is a pressure known as a cell pressure, and due to that there is no shear stress. And then what we do is through the piston we apply some additional load, and due to that additional load some additional stress is going to be developed, and that additional stress is a deviatoric stress. And as the deviatoric stress increases, then the shear stress will be increases. At some point it will fail. So note down the deviatoric stress at failure as a sigma df. So now once we know the sigma 1 and sigma 3, once we know the sigma 1 and sigma 3, see, this sigma 1 is going to be sigma 3 plus sigma d. If it is going to be at failure, then the sigma 1 is maximum. Now once we know that, now I am representing the element as sigma 1 is this one, sigma 3 is this one. So now you plot the Mohr circle and conduct the same test. Similarly for different specimens, you can get different Mohr circles, you can get the failure envelope. And once we know the failure envelope, you can find out all the values of C and phi. What do you mean by different specimen? I did not say any different specimen. I said as identical specimen. Identical specimen is the same soil mass you need to take, not a different specimen. So now you see how to find out U in the table. Nah, just wait. Now look, everybody, stop your things and listen to me. I just introduced the how long we increase the deviatoric stress, sir. Sir, you see, sir, note down the deviatoric stress at which shear failure occurs, sir. We are going to increase it so that whenever the failure occurs, it is going to be stop over there. Now, let's see. See, I got this C comma phi. Okay, fine. The biggest difference between the direct shear test and the triaxial shear test is, in the case of the direct shear test, if you go, there is no control over the dryness. You see over here, there is no control over the dryness. So this test is suitable only for the drained conditions only, which means C dash and phi dash. That's it. Whatever the values I obtained, this will be C dash and phi dash. Because in the case of direct shear test, which type of conditions we are going to obtain? Drained condition. Now coming to the triaxial shear test. If you see the drainage valve, if the drainage valve is going to be open, then the pore water will disappear. Then it is going to be drainage condition. So I can write, if drainage valve is opened, water dissipates and we cannot call it as drained test. So the same test is going to be a drained test. Now, if drainage valve is closed completely, then I can call it as a undrained test, which means what I want to say over here is, in the case of the triaxial shear test, you can open the drainage valve or you can close the drainage valve, which means you can control the drainage. You can conduct the drained test or you can conduct the undrained test. So whatever the parameters, if it is a drained test, you know that these parameters are going to be C dash, phi dash. These parameters are going to be C dash, phi dash. And if it is an undrained test, then they are going to be Cu, phi u. So my dear students, now I am going to play with the drainage. So far I did not say anything regarding to the drainage or not. I just said you the procedure. Sigma 3 you apply, sigma d you apply, get down the major, minor, and find out the failure envelope. Now my question is, does this C, phi are drained parameters or undrained parameters? So now this topic is very important. I'm going to discuss the previous gate and questions. I'm telling you, from this chapter, triaxial shear test is very important, so that 50 to 60% of the questions will be appear from this topic only. I'm telling you 50, minimum 50%, and remaining everything is going to be 50%. So, and especially in the case of gate, keep in your mind. So now, based on drainage conditions, let's go back. You see, how many stages are going to be there for this test? 2 stages are there. Yes or no? What is those stages? Consolidation stage and shearing stage. Listen to me carefully. What is the basic point? You know, if you apply some pressure on a saturated clay, immediately pore water pressure will increase. That's the point, you know. Yes or no? So in the case of consolidation stage, which pressure I am applying? Sigma C. So definitely due to sigma C, in the soil some pore pressure will develop or not. I am a soil. You apply some sigma C, inside of me there is a water. So due to this sigma C, some excess pressure will develop. Now, if I open the tap, see, before application of the piston only, before application of this external load only, before application of the additional load, if I open the tap, what happens? See, first one I applied water. Due to water, the pressure is going to be sigma C. Due to sigma C, some pore water pressure will develop inside of the soil. And if I open the tap, then water will dissipate, which causes consolidation. Water goes out, consolidation is going to be happen. Yes. And sir, if you don't open the tap or if you don't open the drainage valve, what happens, sir? No consolidation. No consolidation, which means unconsolidated. So consolidation, water dissipates. No consolidation, no water dissipates. Consolidation, drained. No consolidation, undrained. Now, okay, sir, first you apply sigma C, and due to that some pressure will be developed, and if you open the tap, the consolidation occur. If you don't open the tap, the consolidation is going to be not occur. So I am going to explain the first test. You have to understand the remaining tests also. So now first one I am applying is stage 1. What is the stage 1? Consolidation stage. Which pressure you are applying? Sigma C. Then excess pressure will develop. If you open the tap, consolidation occur. If you don't open the tap, no consolidation. Now, coming to the stage 2. In the stage 2, we are applying an additional load. Yes or no? Are Baba, when you apply an additional load, now again me, when you apply an additional load, that additional load will also be taken by the water only. Which means In stage 1, due to sigma C, there is a pore water pressure. And in stage 2, due to additional load, again some excess pressure will be developed or not? Yes. So now, in stage 2, if I apply the, means if I open the drainage, then the shearing will be happen. Because if you apply the drainage, means if you open the drainage, then water will dissipate, then the soil starts to shear. If you don't open the drainage, then there is no shearing. So the conclusion I want to say, my dear students, consolidation stage you see over here, and there is a one more stage known as shearing stage. And there are two pressures, sigma C and sigma D. During the two stages, there is a development of excess pore pressure. And if you open the tap, then only water will dissipate. If you don't open the tap, no water will be dissipate. Yes. Now my question is, what if I open the tap completely? What if the drainage is opened completely? If I open the tap drainage, means if I open this drainage valve completely, then in the stage 1 water will dissipate, which means consolidation is going to be happen. In the stage 2, water will dissipate, shearing is also going to be happen. I hope you understood the meaning. Shearing is going to be happen. So such a type of test is known as a consolidated, means consolidation happened, and sheared. Sheared means drained test. So now there comes, based on the drainage conditions, the number 1, first test is going to be consolidated drained test, represented with CD, consolidated drained test. Sir, if we open the valve, then there will be no horizontal forces, then only due to normal force shearing will take place. No, it's not like that. If you open the valve, see, the shearing is going to be happen due to this additional stress now. Due to the additional load, the shear stress is going to be increases. Please look over this one. Not due to the horizontal force over here. That mechanism, direct shear test mechanism is different. Here I am making sure one is major and other one is minor. So consolidated drained test. Consolidated drained test means, in this case, drainage valve is opened in both stages. Drainage valve is opened in both stages. So drainage valve is going to be opened in the both the stages. When the drainage valve is going to be opened in both the stages, then stage 1, water dissipated, consolidated. Stage 2, water dissipated, sheared. Means when the water goes out, the particles will be slide over one each other, right? Because as the water goes out, the particles will be in contact. While the particles are going to be sheared, then definitely there is a shearing. So drainage valve is opened in both the stages. When drainage valve is open in both the stages, complete dissipation of excess pore water pressure. Complete dissipation of excess pore water pressure means, can you please tell me, see, this is fully drained test or not? So now, can I write, this is known as effective stress analysis. So consolidated drained test means you open the drainage, and when you open the drainage, definitely the entire water will dissipate, and you know that at the end, whatever the pressure you applied is nothing but the effective stress. So now, as effective stress principle, now as I said, effective stress is going to be used, which means C dash and phi dash. So in this case, whatever the major principal stress and minor principal stress. See, now there are effective stresses coming over here. Please look, this element, stage 1, which pressure you apply? Sigma C. When excess pressure dissipated, then the sigma C will be acted as effective stress or not? Yes, you know that. Now this sigma 3 dash is nothing but sigma C, because once the excess pressure develop and dissipate, once the excess pressure dissipate, whatever the external pressure will be taken as effective stress. I discussed these points clearly in the previous chapters. And what about the major principal stress? Sigma C plus sigma D. So in the case of the consolidation test, drainage valve is opened in both the stages and a complete dissipation of the excess pore water pressure. So then I can say it as drainage test. And sir, suitable for granular soils. Why for granular soils, sir? Sir, in the case of the granular soils, its permeability is more, sir. So if permeability is going to be more, sir, then only you can go for that drain test, sir. Sir, what if I provide the same test for clays, sir? Sir, in the case of clays, when you open the drainage, the time required for the water to dissipate is going to be very high. Are you going to wait that much time in the case of laboratory? No. So this test is generally used in field. This test is going to be generally used for short-term stability analysis or long-term stability analysis. Think and say. Complete dissipation of excess pressure. So when the water dissipates, when the end of the consolidation, I can say long-term stability analysis. Long-term stability analysis means after a long time of the construction. So this is going to be the consolidation drained test. In the field view, you are going to use it as a long-term stability analysis. Okay. In order to check the long-term stability means as time goes on, excess pressure dissipate, effective stress will increase. I hope you understood this test. Now, my question for you. Second one, think and observe. In this, I opened the drainage in both the stages, right? Now, what if I close the drainage in both the stages? What if I close the drainage in both the stages? If I close the drainage in both the stages, if I close the drainage in both the stages, come on, tell me please. If I close the drainage in both the stages, then when there is no drainage opened in the stage 1, when no drainage, is there any consolidation? No, I can say it as unconsolidated. And in the stage 2, if I don't provide any drainage, then there is no shearing. So we can call it as unconsolidated, undrained test. This is known as unconsolidated, undrained test. The meaning of unconsolidated, UU. The test name is known as UU. In the case of consolidated, CD. See, the first word is represents the test name. Now, in the case of the UU test, drainage valve is closed completely. Drainage valve is closed completely. So no dissipation of excess pore water pressure. When there is no dissipation, no consolidation, and no shearing, then this type of analysis is known as total stress analysis. Total stress analysis, which means CU and phi U. Here, whatever the confining pressure you apply is nothing but total minor principal stress, and this is going to be total major principal stress. So sigma 3 is equal to sigma C and sigma 1 is equal to sigma C plus sigma D when in the case of UU test. This is generally suitable for clays. So example, immediate construction on clays. So immediately construction on clays means you know that in the case of clays, immediately entire pressure will be taken by whom? Water. Then definitely excess pressure is going to be increases. When excess pressure increases, see you go back over here. I told you short-term stability check should conducted as, so in the case of the undrained condition, now you see in the case of the undrained condition, stability check should check immediately after the construction. So now the same thing I am applying immediately after construction on clays. This is for the short-term stability. Are Baba, the meaning of a short term means no dissipation. Short term means time t is equals to 0. In the case of time t equals to 0, no dissipation of excess pressure. Long term, time t is equals to infinity. Excess pressure will be dissipate. When excess pressure dissipate, we call it as a drain test. Long term. When excess pressure is not going to be dissipate, we call it as short term. So I hope you understood this consolidation test and unconsolidated undrained test. Mind it, these are very, very, very important. And then some person is asking me continuously, what is the difference between failure plane and failure envelope? I hope you have gone through the previous chapters. You means the previous yesterday. There I have been explained failure envelope and failure plane. You please go through that, my dear student, because I am not going to discuss about those things. See, if anybody having any doubts in the previous session, I am allowing you to people in the doubt clearing session only, because so due to this in between the doubts, it is taking a lot of time for us. So now let's see the third one. The third one is, now you see you are playing with the drainage valve. Let's play. So first I played by opening the tap in both the stages. Second, I played by closing the tap in the both the stages. So now third one, what I do is I play by opening the tap in the stage 1 and by closing the tap in the stage 2. By opening the tap in the stage 1, see stage 1 consolidation, when I applied the cell pressure, you know that cell pressure and additional stress are not going to be applied at the same time. First, what you are going to apply? Cell pressure or confining pressure. Cell pressure or confining pressure. So we are going to apply, because we are not going to find it, we are going to apply by means of the water pressure. So now at first I apply the cell pressure. Okay, when I apply the cell pressure, I'm a soil, you apply the cell pressure, what happens? If I am saturated, then excess pressure will develop. Now open the drain. When you open the drain, due to the cell pressure, whatever the excess pressure developed will dissipate. Can I say consolidated? Yes. Now during cell pressure, there is no shear stress. Apply additional stress, sigma d. And due to this sigma d, again some excess pressure will be developed in me. Yes or no? In stage 1, due to sigma c. In stage 2, due to sigma d. Now, in stage 1, I open the tap, then water will dissipate, consolidated. In stage 2, I am not opening the tap. When I don't open the tap, then the water won't dissipate. Yes or no? Then excess pressure will be present inside of the soil mass or not. So, sir, if I don't open the drainage in the stage 2, some excess pressure, pore water pressure will be developed, and that pore water pressure will be measured by using the piezometer. So now let's come to this, you see, so this is going to be measured by using the piezometer. So now the third one is consolidated undrained test. Consolidated undrained test. We call it as CU. We call it as CU. So in this, drainage is opened in stage 1 and closed in stage 2. Drainage is opened in stage 1 and closed in stage 2. So partial dissipation of excess pore water pressure, which means excess pore water pressure is not going to be 0, which means there must be some excess pore water pressure or not. And remaining pore pressure is measured by piezometer. So as excess pore water pressure is going to be there, now you see, listen to me carefully. In the case of the first CD test, as I opened the drainage completely, complete dissipation of excess pore water pressure. So which means finally the stress is going to be effective stress, yes or no? And in the case of the unconsolidated, as there is no dissipation of excess pressure, effective stress is 0, then total stress would be there. But in the case of the consolidated undrained, there is a partial dissipation. When there is a partial dissipation, then the effective stress is going to be partial, not full, which means in this case, both total stress and effective stress analysis are going to be there. Total stress and effective stress analysis are going to be there. So here, total stress and effective stress analysis, both will be happened. So now how to find out that total stress and effective stress? So now you see, whatever the sigma 3 you applied, whatever the sigmas you applied, that is going to be total stress as sigma 3, and sigma 1 is equals to sigma c plus sigma d. These are total stresses, yes. But now the question is it a no dissipation? No. Is it a complete dissipation? No. But there is a partial dissipation of water, which means there must be some effective stress. And that effective stress sigma 3 dash is equals to sigma 3 minus pore water pressure. And sigma 1 dash is equals to sigma 1 minus pore water pressure. Sir, how I am going to measure the pore water pressure, sir? The pore water pressure is going to be measured by using the piezometer. So now, in this case, whatever you see, this pore water pressure, I can measure by using the piezometer. So drainage is open in stage 1 and closed in stage 2. This type of test. And example is a structure constructed on clay and load is applied at a rate so that some consolidation will occur. Some consolidation occur. You see this some consolidation. Some consolidation means partial dissipation of excess pore water pressure or not. So whenever some consolidation is going to be occur, then you can call it as a CU test. And immediately after the construction, you tell me, Nana, immediately after the construction, do you think consolidation is going to be happen? No. When there is no consolidation, UU test. And long term. Long term means when there is a full consolidation, we can call it as a consolidated drained test. So I hope you have understood whatever the logics behind I am saying, CD, UU. The point you need to worry about this and drainage valve. See, when if you go for the CD test, then these are going to be C dash phi dash. If you go for the UU test, then these are going to be CU phi. And in the case of the CU test, then both the total stress and effective stress analysis would be there. So now the last note point. Now you may ask me, Are sir, you open the drainage in first stage and you open the drainage in the second stage and closed in both stages. Now you open the drainage in first stage and close in the second stage. Now can I close the drainage in stage 1 and open the drainage in stage 2? It is not going to be possible. See, if I open drainage in stage 1, consolidated, closed in stage 2 and drain. If I close the drainage in stage 1, does shearing takes place in the stage 2? No. In the CUC, Nana, when there is no drainage, then there is no shearing. No drainage, no shearing. Here, drainage is going to be happen in the stage 1. Consolidation occurs. Closed in stage 2, which means no shearing. I write that. Consolidation occur, but no shearing. Okay, fine. So now notice unconsolidated drained test, which means UD is not possible practically. Why, sir? Why it is not going to be possible? Dana, without a consolidation, there is no shearing. Without a consolidation, there is no shearing. First of all, in order to undergo the soil mass shear, it must be consolidated. What is the meaning of UD? Unconsolidated. I told you unconsolidated means no consolidation. D means drainage, shearing. So without consolidation, does drainage is going to be possible? No. So without consolidation, no shearing happens. So that's the reason why we call it as a UD test is not going to be practically possible. Now, how many tests we have been discussed? CD, UU and CU tests. Out of all these tests, which one is going to be quick test? Quick test. Quick test means UU test, because you are not opening any drainage. When you don't open any drainage, then water won't dissipate. You can find out the details easily. So short-term stability, less time. And which one is going to be long time taking? Long-term stability, which is going to be CD test. And what about CU test, sir? Some consolidation occurs means then it is going to be medium test. So out of the all, the unconsolidated undrained test is going to be quick test, because no dissipation, and this is going to be slow test because of the complete dissipation, and this is going to be medium. It is neither quick nor slow. So these are the tests. Now yes, everybody, please have a look over here once. Now, a footing resting on the what is the meaning of drainage is open? As the pore water goes, then the particles will stop to slide. Then only the shearing is going to be happen. If there is no, see why I said you, if there is no drainage, is there any change in volume? Think and say. If there is no drainage, then is there any change in volume? Tell me please. No change in volume. Why, sir? When there is no drainage, sir, no water will go, sir. Volume will decrease when the water disappears. So no dissipation, no volume change. When there is no volume change, then there is no shearing is going to be happen. When shearing occurs, volume will change. So now, a footing is rested on the fully saturated clay. This is ESC, fully saturated clay. For checking the initial stability, shear parameters are used from which one of the following tests? For checking the initial stability means immediate. So immediately means, is it going to be undrained or drained test? Undrained. Consolidated non-drained means consolidated undrained. CU. Unconsolidated drained. UD. This is not going to be practical, possible. Unconsolidated non-drained test means UU. So which test is going to be suitable for immediate settlements? For checking initial stability means immediate stability. Initial means no dissipation of water. Think initial, okay, time 0, initial, time t is equals to 0, no dissipation of U bar, which means UU test. The answer is going to be unconsolidated non-drained test. Sir, why not option D, sir? Unconsolidated non-drained test with pore pressure measurement. See, I don't need to worry about the pore pressure initially, because whatever the pore pressure, that is nothing but the total stress only, right? So I don't need to measure that. So I hope you understood this. Let me give a minute, please. I will. Okay. So as it is going to be initially time t is equals to 0, no dissipation of the excess pore water pressure, which means the test is going to be completely undrained test. Completely undrained test. So we can call it as a unconsolidated non-drained or undrained test. So the answer is going to be answer as C. Now you see this question, one of the question, so this is based upon the yesterday's topic. Consider the following statements. A sand with its void ratio higher than its critical void ratio increase in volume when sheared. Now listen to me this question clearly. A sand with its void ratio higher than its critical void ratio. You know, yesterday we discussed about this is nothing but the critical void ratio, and whatever the soil, this is known as loose sand, and whatever the soil, this is known as dense sand. Sir, if we do not measure the pressure using piezometer, how come you measure total pressure, sir? Sir, Baba, initially if I apply 50 kilopascals, that is nothing but the excess pore water pressure, right? Do I need to measure that? But when some water dissipates, now think, if some water dissipates, then the excess pressure will not be 50. Then you have to measure it by means of the piezometer. Think, understand that during the time t, during time t is equals to t, excess pressure will be less than q. Yes or no? Then here you are going to use the pore pressure measurement, some time t. But initially, excess pore water pressure is nothing but the external load. So I don't need to measure that, right? So now, you see here, a sand with its void ratio higher than its critical void ratio. You know, this is nothing but critical, right? A sand its void ratio higher than its critical void ratio. Array, this is a void ratio which is higher than the critical void ratio. The soil is loose sand or not? Yes. Void ratio increase in volume when sheared? No. See, the meaning of this loose sand is volume is going to be decreases. Yes. You please go through the earlier conditions I have been given to you. You please observe over here. So whatever, this is nothing but loose sand. This is a critical void ratio. Whatever the soil whose void ratio is more than the critical void ratio is known as loose sand. And loose sand, when you apply shearing, during shearing, loose sand compression is going to be occur. Now, first one is going to be wrong. Second one, a sand with its void ratio less than its critical means dense sand ratio increases in volume when sheared. Yes, dilation. You know that in the case of the dense sand, dilation is going to be happen due to that volume increases means the void ratio is going to be increases. So second statement is going to be true. Now coming to the third one, for sand at the critical void ratio, the volume change during shear is minimum, because see, as the volume is going to be reaches to the critical state, then the change in volume is going to be very less. Then this is also going to be correct. So see, the statements are going to be based upon this graph, and this graph I have been discussed about this graph earlier. So from these statements, so statement number 1 is false, 2 and 3 are going to be correct. The answer is going to be only 2 and 3. Answer is C. So you need to apply your logics or concepts in the case of the ESE. I'm telling you again, for the civil ESE students, this chapter is very important. And this has numericals and concepts. I am telling you, out of all the chapters, no matter what, if you understand this chapter, shear strength, that's going to be very beautiful chapter. I'm telling you, this is very beautiful chapter and very nice chapter. So there are a lot of topics, there are a lot of concepts, and we need to make sure ourselves to explore. Why you take that graph? I took this graph because, okay, fine. This is critical void ratio. What is meant by critical void ratio? Here, you see, this is the critical void ratio, right? You see this graph, graph D. What is the meaning of critical void ratio? This is the critical void ratio. And whatever the void ratio more than critical void ratio, that is loose sand. Yes. And what is the nature of loose sand? Void ratio is decreasing, right? Void ratio decreasing means volume decreases or increases? Decreases. But what they mentioned over here, volume is going to be increases. So statement number 1 is going to be false. So the statement number 2 and 3 are going to be true. Now, the one question I want to show you. Yes, see this question. These are previous ESE 1999. What is dilatant, sir? My dear students, I am really requesting you, you please go through the previous notes. See, I have clearly mentioned, right? What is meant by dilation? Dilation means increase in the volume. And if I say this one also, then after all these things, if you're asking the same doubt, then what is the purpose of stressing myself too much to give you more information and more knowledge? Tell me. Just think about that. What is the purpose of discussing all these things? Yes, if you ask me a doubt which is going to be beyond the scope, I'm very happy to explain. But if you're asking the same doubt what I explained in the class, then means either you people are not able to understand my class or you people are not studying in the home. So that's the two reasons only, and I'm leaving that to you. Okay, fine. Yes, you please look over this question. Question number ESC 1999. So now in this question, please observe stability of a clay foundation. Say I am giving you list 1 and I am giving you list 2. So list 1 I am taking the field problems, list 2 type of laboratory shear test I want. So stability of a clay foundation on an embankment whose rate of construction is such that some consolidation is going to be occur. Just now I said you, if there is a some consolidation, then I can say the test is going to be related to partial dissipation, which means CU test, consolidated undrained test. Just now I mentioned you, if there is a some consolidation is going to be occur, they said it, some consolidation occurs, which means at some time t is equals to t. At some time some t is equals to t, some consolidation occurs. So I can go for the consolidated undrained test. So for A, that's going to be 3. For A, it is going to be 3. I eliminate option A and option B. And now my question is, I have to look over option C and option D. Now, you go for initial stability of footing on a saturated clay. Initial stability means no dissipation of excess pore water pressure, which means undrained test. Think, Nana, think that's it. So in the case of the initial stability of footing are immediately after the construction, short-term stability or initial stability, I'm telling you like any time, n number of times, short-term or initial or immediate, no dissipation, which means undrained test. So for B, what is this test? This is going to be undrained test, which means for B, the answer should be 1. For B, answer is going to be 1. So in C and D, the answers are going to be same. Now, the meaning of long-term stability of a slope in fissured clay. The meaning of long-term stability means dissipation of excess pore water, which means drained test. So the long-term means drained test. I told you if it is a drained test, long term. So answer is going to be drain test. For C, it is going to be 2. For A, it is going to be 3, consolidated drain test. For B, it is going to be 1. For C, drain test, it is going to be 2. Foundation on soft marine clays, we are going to use a vane shear. Vane shear test we are going to use. So that we will be discussing later. Now, what is the answer? Answer is going to be C. See, you please remember one thing. I'm asking you, if I go for the short term, immediate, short term, no dissipation, and drain test, total stress. Long term, water will dissipate with respect to time, drained test. Long term means you are allowing the water to drain test. Short term means you are not allowing the water to drain, which means no dissipation and drain test. I hope you understood the meanings of drained and drained test over here. So generally this test is going to be UU test and this test is going to be CD test. So CU, some consolidation occur, and UU test where we are going to use for initial stability of footing, and for long-term stability of footing we are going to use CD test. So that is the reason why we have a different test with us, and that different test I explained as CD test. So long-term stability analysis, UU test, short-term stability analysis, and CU test, some consolidation is going to be happen. Now, let's see the results from triaxial test. So you please make it as a very important, because this is the heart. This is the heart. So not heart, this is heart. And based upon this only, I am going to discuss about CRPQ. So see, so far I did not discuss any CRPQ because you need all these details. You need all these details. Every point, pinpoint, you need to understand the concept. Now, with this, I'm going to solve n number of problems. Result from the triaxial test. How many triaxial tests are there? CD, UU, and CU. So now, first one. In the case of CD test, this is going to be a completely drained test. You know that it is going to be a completely drained test. So when it is a completely drained test, yes, when it is a completely drained test, C dash and phi dash. So now what happens over here is, if it is going to be completely drained test, now you see whatever the failure envelope is there or not. You observe this is a failure envelope. Now question is, does the failure envelope in CD test, UU test and CU test are going to be same? No. So now what are the results we are going to obtain by conducting the test are, what are the results that we are going to get, sir? Sir, if it is a loose sand or normally consolidated clay, I told you in the previous session. So I have said you one point in the previous session. That point was, you see, like in science, behavioral change is same in clays also. Loose sands and NCC are similar to each other. Dense sand and OCC are similar to each other. So now the same thing we are going to use, loose sand or NCC and dense sand or OCC. See, in the case of loose sand or NCC, in the case of loose sand or NCC, in the case of the loose sand or NCC, there is no cohesion at all. Because see, what is the meaning of drainage test? Think clearly and tell me, what is the meaning of drainage test? Now you see, these are the particles, right? These are the particles. Drainage test means water will dissipate. And when the water is going to be dissipate, then the particle to particle contact would be more or not? When the particle to particle contact would be more, then the strength between the particles is more of friction between the particles, which means, look, if these are the particles, now let's say these are some water molecules present in the particles. Listen to me carefully. Now, in the case of the shearing, you please look over. In the case of shearing, and that too, if the test is going to be drained test means whatever this water will dissipate, the water will get dissipate, and you see the contact between the particles would be more now. In the case of the drain test, the contact between the particles are going to be more, and the strength offered is nothing but the friction. Whatever the strength offered is nothing but the friction. Just simply what I say is, if you walk on a wet floor, friction is less. But if you walk on a dry floor, friction is going to be more. I hope you understood. Friction is going to be more. So now you please listen and understand this point. The point is in the case of the drained condition, as water goes out, the friction between the particles increases, results in the strength. So now if I draw, means after conducting the test, whatever the test, if I means for the CD test, if I draw the more circles, and now at the end the result that I am going to get over here is simply the graph is going to be passes through the origin, which means C dash is equals to 0, and this is going to be phi dash. So now the first and foremost important point is the C and phi are not properties of soil. That depends upon the type of soil and that depends upon the drainage condition. If the test is going to be a CD test on the NCC or loose sand, on the NCC or loose sand, my dear students, you please see on the NCC or loose sand, C dash is equals to 0. So for CD test on NCC, what is the meaning of NCC? Normally consolidated clays, C is equals to 0. C is equals to 0. See, if I represent C, you know that in the case of CD, that is nothing but C dash and phi dash. When C represents 0, then what is phi value? Sine inverse of major principal stress minus minor principal stress by major principal stress plus minor principal stress. Arey sir, how come it is going to be possible, sir? Sir, I told you, sir, earlier also. You please go through this failure envelope, sir. Everybody, sir, have a look, sir. When C equals to 0, sir, then what is the phi value, sir? Phi is equals to sine inverse of major minus minor by major plus minor. I'm telling you, students, this is very, 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 very important. Either I can use the plastic equilibrium equation. See, you can go for the plastic equilibrium equation or you can go for the logic. Logic is from the Mohr circle. If you want me, I can say the thing again here also, but already have been discussed. Because if the Mohr circle is going to be passes like this, then sine phi is nothing but radius by sigma 1 plus sigma 3 by 2. You can find this one. So I have given you this explanation earlier. Now, in the case of the denser sands or OCC, in denser sands or OCC, due to interlocking, some cohesion which is known as and due to interlocking, some strength would present as cohesion. And one more thing, in denser sands especially, yet low moisture content, due to capillarity, some apparent cohesion is going to be present. Some apparent cohesion is present. See, in the case of the dense sands, now, yet low moisture content. Have you remembered the bulking of sand? Have you remembered the bulking of sand? I hope you remembered. I told you there in sands due to capillarity. So due to capillary film would be there or not? And due to that capillary film, the particles are going to be closely packed. I don't have that point over here, but you please go through. In the compaction chapter, I told you clearly in sands, yet low water content, capillarity is going to be present. Due to capillarity, particles won't move that much easily, and that has some strength, and that strength is known as apparent cohesion. We call it as apparent cohesion. So now in the case of the dense sand, some apparent cohesion would be there. Some cohesion would be there. So now if I draw, the failure envelope is going to be having some apparent cohesion. You please see this as apparent cohesion, and this is going to be 5 dash. So whatever, this is nothing but the apparent cohesion C dash. So the most important point here is this conclusion. And this conclusion is very important in the case of the examinations. You will be seeing just in a few minutes, you will be seeing this one. Now, this is CD test. Similarly, next. Second one, UU test. In the case of the UU test, fully undrained test. When it is a fully undrained test, you take any soil mass. You take any soil mass, whether it is NCC or loose sand, OCC or dense sand, which means for all soils, what happens over here is, so once I draw the result is going to be looks like friction is going to be 0. Friction is going to be 0. See, in the case of the UU test, phi u is equals to 0, and this is going to be Cu. So what is the point over here, sir? What is the connectivity between capillarity and cohesion, sir? Sir, due to capillarity, particles will have more contact, sir, and that will induce some apparent cohesion, means attraction between the molecules are going to be present, and that too at low moisture content only. That's the characteristic of the sand now. That's the characteristic of sand. I am telling you, please understand this. This is at a low moisture content only, and if the moisture content is going to be increases, then the capillarity will break down. I told you these points clearly in chapter number 12, compaction. If the moisture content increases, capillarity breaks down and cohesion is going to be decreases. So now, NCC or loose sand. In the case of the loose sand or NCC, whatever you take, what is the meaning of undrained? Tell me. What is the meaning of undrained? Array, these are the particles. The meaning of undrained is water would be there. Array Baba, when the water is going to be there, you please tell me, Nana, when the water is going to be there, can you walk on the wet floor? Can you walk on the wet floor? No. On the wet floor, friction is going to be completely 0, which means phi is equals to 0. So no matter whatever the soil you take, in the case of the UU test, here phi u is equals to 0. And you know that when phi u is equals to 0, when phi is equals to 0, what is C? Sigma 1 minus sigma 3 by 2, which is nothing but tau max or not? Yes or no? Or in simple words, I can write as sigma d by 2 also. What is meant by sigma d? You please look over here. What is meant by sigma d? Sigma D is nothing but major principal stress minus minor principal stress, right? So I can write the conclusion as, this is the conclusion. You please look over here. So in the case of the UU test, phi is equals to 0 degrees. Sir, how come it is going to be C value, that one, sir? You please look over this value, sir. I have explained, sir. If phi is equals to 0, sir, then what is going to be happen, sir? Then if C, then phi 0, then C is equals to tau max is equals to sigma 1 minus sigma 3 by 2. This is pure cohesive soil, but here we are discussing about whom? A UU test on any soil mass. So this is the result that we are going to get. That you need to remember this. And the last one. Third one, CU test. In the case of the CU test, total stress and effective stress analysis would be there. Total stress and effective stress analysis would be there. So can you please tell me what is effective stress? Total stress minus pore water pressure. Yes or no? Yes. So everybody listen. This is sigma and this is tau only. Okay. This is sigma and this is going to be tau. This is sigma and here it is also going to be tau. Okay. Now, in the case of the CU test, look. For the sake of explanation, I am going to draw. You see, if this is the total stress graph, if this is a total stress graph, then what about the effective stress? What is effective stress? Total stress minus pore water pressure. Okay. Then if it is going to be effective stress, please observe carefully. Then sigma 3 dash is nothing but sigma 3 minus u. Sigma 1 dash is nothing but sigma 1 minus u. Are Baba, this is sigma 3 and this is sigma 1. And what is sigma 3 dash? Then this graph would be near to the origin or not? Yes or no? So this is going to be near to the origin. This is going to be near to the origin. Then this is sigma 3 dash. And this is sigma 1 dash. So you please observe carefully. Now let me remove all these things once again. I'll explain you. What I want to show you over here is, listen, if this is going to be sigma 3 and this is going to be sigma 1. Now, my dear students, my question is, this is total stress, yes or no? And if I want to go for the effective stress, then I have to remove the pore water pressure. When I remove the pore water pressure, then the graph would be shifted towards the origin. Then the graph would be shifted because sigma 3 dash is less than sigma 3. And sigma 1 dash is less than sigma 1. Sigma 3 dash is less than sigma 3 and sigma 1 dash is less than sigma 1. Now, if you draw the failure envelope, just simply, let's imagine. Now, this is going to be the failure envelope for the total stress, where I can write as a phi u, and this is going to be the failure envelope for the, because what is meant by failure envelope? Failure envelope must touch us at one point on the Mohr circle. Now this is going to be phi dash. So my dear students, the red I am representing you as a total stress. Total stress means phi u. The black I am representing as the effective stress. Effective stress means phi dash. Now you please tell me which one has more friction angle, effective stress or total stress. Don't think phi dash and phi u are going to be same. Don't think phi dash and phi u are going to be same. So now from this topic, I can understand that if I draw the Mohr circle for the effective stresses, the Mohr circles will be near to the origin so that the slope is going to be more. if I draw the Mohr circle for the total stress, if I draw the Mohr circle for the total stress, then the failure envelope has a lesser slope. So using this concept, what I want to write over here is sigma 3 dash means sigma 3 minus u, sigma 1 dash means sigma 1 minus u. So again, this is sigma and here is going to be tau. And in the case of NCC or loose sand, if you plot a graph, the graph would be like this one. The graph would be look, in the case of NCC or OCC, this C value is equals to 0 and this is nothing but phi dash and here it is going to be phi u. Just now I mentioned you for the total stress, Mohr circle is going to be more, then the failure envelope slope is going to be less. Phi u is going to be less than the phi dash. Keep that in your mind because sigma 3 dash is less than sigma 1 dash, then the Mohr circle will move towards whom? Origin. When the Mohr circle moves towards origin, then the slope, failure envelope slope is going to be more. So this is for the NCC and loose sand. See, this is exactly similar to the drain test or not. Again, for CD test, NCC is going to be C0. For CU test also, NCC is going to be C0 and phi becomes sine inverse of major minus minor by major plus minor. In the case of dense sand or OCC, in the case of dense sand or OCC, if you draw the failure envelope, if you draw the failure envelopes, so now this will represent C dash and this will represent phi dash, and whatever this value, this will represent the CU and this will represent the phi u. So my point, my dear students, I want you to remember is in the case of UU test, phi is equals to 0. If I say undrained, undrained means immediate. Immediately friction is going to be 0. The meaning of undrained means, what is the meaning of undrained? No dissipation. Loading is quick. If the loading is quick, water won't dissipate. Then due to water present between the particles, friction is 0. So for UU test, friction is going to be 0. And for the CD test, drain test means long term. Water dissipates, then the strength between the particles is mainly due to the friction. So cohesion is going to be 0. And in the case of the CU test, for NCC and loose sand, as there is a consolidation, consolidation means water will dissipate or not. So when the water dissipates, then the friction comes into existence. And in the case of the dense sands, due to apparent cohesion, some cohesion would be there. So this is the final things. And for CU and CD tests on NCC, C is equals to 0. So this is the point I want to mention you, and mind it. See, these are not the things that I have been derived. These are the things that we got from the tests. So, and I told you the reasons behind it. These graphs, So from these graphs, now how we are going to utilize? Please remember these points. These are very, very important points. And now, based upon these points, let's solve some previous gate questions. And see, I'm going to solve the classroom practice questions also. But first of all, I want you to be ascertain that you are going to be completely aware of what type of questions you are expecting in GATE and IES. Now, you see how many questions I'm going to solve based upon the test results, based upon the type of test, and based upon the triaxial shear apparatus. Yes. Okay. These are the previous gate questions. Yesterday I have been discussed, means day before yesterday. Now you see, for a saturated cohesive soil, observe this question. For a saturated cohesive soil, a triaxial test yields the angle of internal friction as 0. Then the conducted test is, see, for a saturated cohesive soil, they are saying when the phi is equals to 0, when phi is equals to 0, just now I told you it is a completely undrained test. Think, remember, when there is no drainage, water will be there. Due to water, friction is going to be 0. Then what is the type of test we are going to conduct? Unconsolidated, undrained test. So answer is going to be D. The meaning of phi 0 just now I mentioned. You know that when phi is equals to 0, then the graph is going to be looks like this one. Phi 0. So when the phi is going to be 0, this is going to be the C. And what is this test? UU test. The result is from the UU test. So the answer is going to be, in the case of the UU test, phi 0. In the case of CD test, C is going to be 0. Now, this we'll be discussing later. Yes. Now you please look over these questions. This is a numericals. Sir, how for drained test psi is 0 and for drained test? Just now I told you, Nana, in the case of undrained test, water won't go out. Just imagine yourself, water will be there means wet floor. Walk on the wet floor. Do you have any friction? No. If you walk on the dry floor, friction is going to be there. So I use the same basic principle. So yes, I give you the break, just wait. Sorry, this is a CRPQ or previous gate. This is a, see, I'm look over here. This is previous gate questions. I am looking and telling you. Just wait a minute, Baba. Just wait a minute. Yes. So now, gate 2002. In a triaxial test carried on the cohesionless soil. So, meaning of cohesionless. What is the meaning of cohesionless soils? C is equals to 0. You know, when C is equals to 0, phi is nothing but sine inverse of major minus minor by major plus minor. Do you want any proof for this? You please go back to the previous class, or I can go by means of the plastic equilibrium condition also. That's not a big deal for me. So now, as it is a gate, I want to reduce the time. Now you see, this is a 2 marks question. This is 2 marks question from the previous gate. This is 2 marks question. Now, how much time it will take? Once I know it is a cohesionless soil sample, then I can say C is equals to 0 and phi is equals to sine inverse of major minus minor by major plus minor. What is the cell pressure I applied? Cell pressure means 20 kilopascals. What is the deviatoric stress I applied? Sigma D, which is going to be 40 kilopascals. So from this, can I write the minor principal stress is nothing but the cell pressure, which is 20 kilopascals, and major principal stress means sigma C plus sigma D, which is 20 plus 40, which is going to be 60 kilopascals. 60 kilopascals. Then what is phi value? The angle of internal friction, sine inverse of major, 60 minus minor by 20 by 60 plus 20. 60 minus 20, 40. 60 plus 20, 80. 40 by 80, 1 by 2. Sine inverse of 1 by 2. Can I say directly that is going to be 30 degrees? The answer is going to be answer D, which is going to be 30 degrees. So this is a 2 marks question, which we have been discussed in GATE 2002. So why not see you in the last question? What is the meaning of see you in the last question? This is the question. Why not see you in the last question? Arey Baba, please, when you are asking question, please look over now. You please look over. In the case of CU, that's phi is equals to 0. Think when phi 0, what is the test? Undrained test. Okay, fine. It will be there. Now, I want to find out this GATE 2017 set 1. GATE 2017 set C. All the questions I am going to do just by keeping one thing in my mind. That point is what type of test or what type of soil. I told you the drainage condition C comma phi depends upon type of soil and drainage condition. If it is a cohesionless, C0. If it is a cohesive, phi 0. And if coming to the drainage conditions, now what is the type of test I am giving you? CU. CU triaxial compression test is conducted on a normally consolidated clay. Just now I mentioned you, if the test is a CU test on the NCC soil, then C is equals to 0. And C is equals to 0 means then C dash is equals to 0 and CU is also going to be 0. Just now I mentioned, right? So if you want, you can go back. CU test on the NCC, C is equals to 0. C means C dash is going to be 0 and CU is also going to be 0. So CU is equals to 0 and C dash is also going to be 0. Now simply I can write it as C is equals to 0. I know that C is equals to 0. Then what is phi? Sine inverse of major minus minor by major plus minor. Now, by seeing the first data CU and normally consolidated clay, I got to know C is going to be 0. Now, you please look over. So, please have a look. The deviatoric stress at failure is 80 kilopascals and confining pressure is 100 kilopascals. So, given confining stress is going to be 100 kilopascals and deviatoric stress at failure is going to be 80 kilopascals. Okay. And now the pore water pressure measured, you see they have given the pore water pressure. I told you in the case of the CU test, it is going to be partially dissipated. So some pore water pressure would be there that can be measured by using the piezometer. So what is the pore water pressure I mentioned? 50 kilopascals. Okay. Now the effective angle of internal friction. Am I asking you phi dash or C dash? Am I asking you phi dash or phi? Listen to me. Am I asking you phi dash or phi? I'm asking you phi dash. So as you know, C dash is equals to 0. Phi dash is equals to sine inverse of major minus minor by major plus minor. But these are effective stresses. Keep that in your mind. These are effective stresses. They're asking you effective angle of internal friction. So from this data, what is the total stress? Please tell me. 100. What is the total stress? First of all, you find out the total stress. Sigma C plus sigma D, 100 plus 80, which is going to be 180. And sigma 3, which is going to be sigma C, which is going to be 100 kilopascals. These are the total stresses. Now let's go back to the test. You please look over here. In the case of the consolidated undrained, first I find out the total stress, and whatever the pore water pressure I measured, now I am going to find out the effective stresses. Now I am going to find out the effective stresses. So effective stresses means sigma 1 dash is nothing but sigma 1 minus u. So 180 minus 50, which is going to be 130 kilopascals, and sigma 3 dash is equals to 100 minus 50, which is going to be 50 kilopascals. Now substitute please. Phi dash is nothing but sine inverse of major 130 minus minor T by 130 plus 50. Can you please tell me these values? 130 minus 50 by 130 plus 50. So sine inverse of the value is going to be 26.38 degrees. But I am asking you up to 1 decimal. Up to 1 decimal. So when I ask you 1 decimal, then 26.4 degrees. So 1 decimal. This is the phi dash value. This is the phi dash value. Sir, why don't we consider effective stress? Why don't we consider? See, this is very, very simple logic. See, this question for first time, I'm telling you without keeping my pen on the paper also I can solve this question, because once we know the logic is the test. Which test? CU. What is the soil? NCC. Then what is 0? C. What is phi? Sine inverse. In the same question, if I would have asked you, then what is the total R phi u? If I ask you phi u. B, if I would have asked you phi u, then what is value? Then phi u is equals to sine inverse of total stresses. Now this is going to be total stress. See, in the effective stress, we can use the effective principle. Why I want you is I want to just check you. I want to show you one thing over here. Now can you please tell me what is phi u, please? Sine inverse of major how much? 180 minus minor 100 by 180 plus 100. Please tell me this value. Sine inverse of 80 by 280. What is this value, please? 16.6 degrees. Come on, my dear students. Look, I have given you which test? CU test. In the question they ask phi u. So answer is going to be 28.4 degrees. Now I want to show you one thing over here. I find out phi dash. I find out phi u. You see, phi dash is greater than phi dash 26.4 degrees, phi u 16.6 degrees. So phi dash is greater than phi u or not? Now let's go back over here. You see, which is more here? I am representing you phi dash, phi u. I told you phi dash is going to be more than phi u. Now I have represented you in the question also, so you can understand from this I can represent that phi dash is going to be more than phi u. I hope you understood the meanings. My dear students, please, I'm telling you again this point again and again. While you are solving the numericals, you please look whether the soil is cohesive or cohesionless, or whether the test is going to be CU or CD or UU. There are a lot of questions like this. I hope you understood the meaning behind this one. Now, this question I will be solving at the end. Yes, come on. You see this ESC question once. Which one of the following figure gives the failure envelope for what type of soil? NCC. Under drained condition. Drained condition, whether it is going to be CD test or CU test, what is the type of soil? NCC, you know that C is equals to 0. When C is equals to 0, now can you please tell me what is the failure envelope? Answer is going to be A. So the point is whether it is drained test or not. Yes. Drained test means CD. CD means you can see directly the normally consolidated test CD. And if the soil is NCC, then C is equals to 0. Then this is the failure envelope I have been discussed. So answer is A. This is the previous ESC question. Now, please look over everybody here. Now, please look over here. A triaxial test was conducted on whom? Granular soil. Granular soil means cohesionless soil. Everywhere, when I say cohesionless soil, C is equals to 0. That's it. Now, the effective minor principal stress they have given sigma 1 by sigma 3 is equals to 4. The effective minor principal stress, given as 100 kilopascals, and the values of approximate phi and principal stress difference at failure. Look, they are asking you phi value. What is phi value? Sine inverse of major principal stress minus minor principal stress by major principal stress plus minor principal stress. See here, whatever this ratio, the ratio C, you know that for the granular soils, the test is going to be drain test. You know that simply. And whatever the values I am going to get is nothing but, you see, I can directly say this is going to be the effective stress. These are the ratios, effective stress ratio only. Then what is sigma 1? 4 into 100, which is going to be 400. Then what is phi value? Sine inverse of 400 minus 100 by 400 plus 100. So can you please find out this value? Can you please find out this value? See, sir, I don't have a calculator, then what to do? So then sine inverse of 300 by 500, 3 by 5. Listen to me carefully. Listen to me carefully. Over here, this is going to be 3 by 5. 3 by 5 means just more than 0.5. Just more than half. Sine inverse of half is 30 degrees. Just more than half, I can say it as 37 degrees. If you solve, this is going to be around sine inverse of 3 by 5. So 36.86 degrees, which means 37 degrees. And the principal stress difference. So difference sigma 1 minus sigma 3 is equals to 400 minus 100. Answer is going to be 300 kilopascals. So answer phi is equals to 37 degrees and sigma 1 minus sigma 3 is equals to 300. So they have given the effective minor principal stress now, then we have taken total stress. I'm telling you, in the case of granular soils, whatever the stress you applied, the sigma 3 is sigma C is nothing but the effective principal stress, because I told you in the case of CD test generally is suitable for whom? Granular soils. Whatever the stress is nothing but the applied stress sigma C, and this is going to be sigma C plus sigma D. I hope you understood this. Please go through this once again. Yeah, there are a lot of questions to be solved, and after the break, I am going to spend more time in solving the problems only. Yes, so I'll be giving these questions also. Now, meanwhile, now I'll give you a break. I'll give you a break. So, meanwhile, what you do is, these are the IS questions. You please look over these questions. So meanwhile, I'm giving you break now. It's 11:20. Take a break up to 11:40. Take a break up to 11:40. I'm giving you a break now. 11:20. I hope you people understood the conditions over here. So the major thing that I want you to people understand here is these things. What are the test results? What are the test results? These test results are very, very important. So you please go through these test results. So once you know these test results, so then you can find it out. Now I'm giving you a break. Let's have a break up to 11:40. And after the 11:40, I'll start the class. As most of the students were asking, sir. Yes, sir, in this question, they have given the effective minor principal stress. See, in granular soils, what is the test we are going to conduct? Drained test, which means the stresses given will be taken as effective stress. See here the ratio of the major principal stress to minor principal stress is sigma 1 dash and sigma 3 dash, and this is going to be sigma 3 dash. Then everything is going to be total, effective stress on. And see, mind it, did they mention any pore water pressure over here? No. As they did not mind any pore water pressure, then when the pore water pressure is going to be 0, you know that total stress, drained thrust means pore water pressure is going to be 0. Then effective stress is equals to total stress. Have you remembered this point? When the pore water pressure is going to be 0, then effective stress and total stress both are same. So I don't need to worry about they have given the effective minor principal stress because they did not mention any pore water pressure. So that's the reason why I took this one. Now, let's see one more question over here. Let's come to, this is a previous ESC question. This is previous ESC question. Now, a soil sample is tested in triaxial compression apparatus. Failed at total maximum and the minimum principal stress as 100. So what is the total maximum? 100 kilopascals. And the minimum principal stress as 40 kilopascals. Now you see everybody, they have given the pore pressure measured at a failure was 10 kilopascals. Then the effective principal stress, they're asking the effective principal stress ratio. See, stress ratio means major principal stress by minor principal stress. So you're not replying for my request. We requested you to upload recorded videos from day 7. See, I told you clearly that's not depend upon me. I'm telling you, I'm a faculty over here and I'm not the person who uploads the videos also. I have already intimated this situation to the team, corresponding team. So they will take a decision upon that and they will act regarding to this. And if you have any doubt regarding to the subject, you ask me, I can clear you from the day 1 also. Now, you see here, they're asking effective principal stress ratio. What is effective major principal stress? 100 minus 10, which is going to be 90. What is effective minor principal stress? 40 minus 10, which is going to be 30. So effective principal stress ratio means sigma 1 dash ratio principal stresses, right? So 90 by 30. Answer is going to be 3. This is also one of the previous ESC question. So you can observe without using calculator, I am solving these things. So sigma 1 dash by sigma 3 dash is equals to 90 by 30 is equals to 3. Now you see this question. This is assertion and reason type. Shear strength parameters C and phi vary with respect to drainage conditions. Yes, I told you C comma phi are not properties. They are depends upon the drainage conditions. Now, shear parameters C and phi are depend on the water content. Yes. So as C comma phi depends upon the water content, then if you open the drainage, then the parameters are different. If you don't open the drainage, parameters are not going to be different. So assertion A is true and reason R is also true because C comma phi depends upon water content. If you open the tap, pour water dissipate, drained. If you don't open, undrained. So C and phi for drained and undrained are different. So it depends upon the water content. So assertion is true and reason is also true and reason is correct explanation of the assertion. So answer is going to be A. Answer is going to be A. So these are the previous ESE questions, and I have given you this question also. Now, yes, please look over this question. Consider the following statements. Now, the maximum shear stress. See, I told you the maximum shear stress conditions and all those things. The maximum shear stress is 1/2 of the normal stress in the case of uniaxial stress field. The meaning of uni means one. If this is an element, uniaxial means I apply the load in only one direction. On the other direction, the load is going to be 0, which means sigma 1 is equals to sigma 3 is equals to 0. This is known as uniaxial load. Then what is the tau max? You know, the tau max is nothing but major principal stress minus minor principal stress by 2. You know that, right? Major principal stress minus minor principal stress by 2. If you want to, you please go through the yesterday's class. There I discussed you what is tau maximum. Tau maximum is nothing but the radius sigma 1 minus sigma 3 by 2. Then sigma 3 is equals to 0. Then sigma by 2. So the maximum shear stress is 1/2 of the normal stress in the case of uniaxial stress field. The meaning of uniaxial, one axial. So in the vertical direction only there is a load. In the lateral direction there is no load. So then what is the tau sigma? 1/2 of the sigma, which means this statement is going to be correct. Now, in the case of biaxial stress field, now this is biaxial. What is the meaning of biaxial? Uniaxial. Now this is going to be biaxial stress field acted upon by normal stresses accompanied by shear stresses. So now not only this one, but also there is a accompanied by the shear stresses. This is tau xy sigma 1 and sigma, let's take it as okay, sigma y, and this is going to be sigma x. This is going to be tau xy. So if I take biaxial stress field acted upon by normal stress accompanied by the shear stress, the maximum shear stress is any one of the normal stress. The maximum shear stress is any one of the normal stress. Always the tau maximum, you take any value, the sigma 1 minus sigma 3 by 2 only. This is going to be always sigma 1 minus sigma 3 by 2 only. So tau maximum value, you take a biaxial, see, and moreover they have given the shear stresses, right? This is known as solid. In the case of solid mechanics, you are going to see these elements also. So always the tau maximum is going to be major principal stress minus minor principal stress by 2 only. They are not going to be any one of the normal stress. This is not going to be true. Now, the Mohr circle will be tangential to vertical axis in the case of uniaxial field. Now again, uniaxial. So just earlier I took sigma 1 is going to be sigma 3 is equals to 0. Now if I draw the Mohr circle, sigma 3 is going to be 0 and this is going to be the Mohr circle, then sigma 1 is going to be some sigma. Now the Mohr stress circle will be tangential to vertical stress. Now you see this is nothing but the vertical axis R naught, and this Mohr circle, this is going to be acts like a tangent. So this is tangent to Mohr circle. What is meant by tangent, Nana? Tangent means a line touching the circle at one point. So whatever the vertical axis in the case of uniaxial stress field is going to be tangent. So now 1 and 3 are going to be correct. I hope you understood. So for the uniaxial, I am taking sigma 1 as sigma. Uniaxial means the lateral is going to be 0. And if I draw the Mohr circle, sigma 3 0 means then the Mohr circle will start at the origin, and whatever the vertical axis will act like a tangent to the Mohr circle. So these are the ESE questions. And there are some other questions which require some other concepts. So I'll be discussing those things later. Now, yes. In a undrained triaxial test, what is the meaning of undrained? What is the meaning of undrained? Now, everybody have a look. Delta U, undrained. Sorry. Undrained. No expulsion of water. When there is no expulsion of water, then the change in volume is going to be 0. How many of you will agree with this? When there is no expulsion of water, change in volume is going to be 0. When the change in volume is going to be 0, now, if I take a three-dimensional element, this is a vertical stress, major principal stress. This is sigma 3, and this is perpendicular to the board, sigma 2. Sigma 1, sigma 2, and sigma 3. The meaning of the undrained is change in water, change in volume is going to be 0, which means strain in lateral direction is 0. So what is the meaning of a strain in the lateral direction is going to be 0? So E3 is equals to 0. I hope you do remember from the strength of materials concept. From the strength of materials concept. You know that. Now listen to me carefully. If you apply a load on the soil mass, in that load means in that direction, if you apply load, there is a longitudinal deformation, there is a lateral deformation. Now everybody please listen to me. This is a strain in the lateral direction is going to be 0. What is a strain, sir? Sir, now you see, sir, due to this in the longitudinal direction, the strain, if you remember, strain is nothing but stress by Young's modulus. Stress by Young's modulus. And you know Poisson's ratio. Poisson's ratio means minus lateral by longitudinal strain. Minus lateral by longitudinal strain. See, actually this topic should be covered in the strength of materials. Then you can understand. But you know, everybody has done the BTech, right? And everybody is doing the BTech. So don't ask me, so what is the Poisson's ratio and all those things. Longitudinal strain. So now, in this, first of all, due to sigma 3, in this direction, what is the strain? So due to sigma 3, the longitudinal strain, what is this acting over here? Sigma 3 strain means sigma 3 by E. Okay. Now, due to this sigma 3, see, I am applying sigma 3 in this direction. Then in that direction, soil will undergoes compression, and in the lateral direction, it undergoes tension. Yes. So now in this direction, what is the strain? Strain is nothing but due to this load sigma 1, in the horizontal direction, there must be a strain known as lateral strain. Yes. And lateral strain is nothing but mu into longitudinal strain. So now, what is the longitudinal strain due to sigma 1? Longitudinal strain due to sigma 1 is a sigma 1 by E. But I want in the lateral direction, so minus mu into sigma 1 by E. Because the lateral means mu into longitudinal strain minus. Similarly, due to sigma 2, mu into sigma 2 by E. And now, in triaxial test, sigma 2 is equals to sigma 3. Sir, why, sir? You please go. In the case of the triaxial test, now you see, whatever this is element or not, Now you know this is going to be sigma 1, this is going to be sigma 2. The all-round pressure is going to be same or not? The all-round pressure is going to be same. So this is sigma 2 and this is sigma 3. This element, whatever perpendicular to the board, this is going to be sigma C and this is also going to be sigma C. But sigma 1 means a sigma C plus sigma D. So the all-round pressure is going to be same. The all-round pressure is going to be same. Yes. So now sigma 2 is equals to sigma 3. Then I can write directly this one as a sigma 3. So as sigma 2 is equals to sigma 3. Now you send a E value is equals to 0. Then sigma 3. I want mu, right? I want a mu. So what I do is sigma 3 minus mu into sigma 1 minus mu into sigma 3 is equals to 0. So now I can take this minus to the other side. Then from this I can write mu is equals to sigma 3 by sigma 1 plus sigma 3. So sigma 3 by sigma 1 plus sigma 3. Answer A from this. See, this is a topic that you have to discuss in strength of materials. I hope in strength of materials are stress concepts. So the people who have been completed the strength of materials, you have seen all these things in chapter number 2, simple stresses and the complex stresses. There you have seen the volumetric strain, longitudinal strain, lateral strain. I hope you understood. So this is a lateral strain. Yes. So now with this I can say the answer. Okay, fine. Sorry. Okay, fine. As some of the people are asking me, look, I'll take my board. Now, everybody, if there's an element acting over here, if there is an element acting over here, now due to this load sigma 1, this is sigma 3 and sigma 2. In triaxial test, sigma 2 is equals to sigma 3 is equals to all round pressure, which is nothing but sigma C. Sigma 2 is equals to sigma 3 is equals to sigma C. And you know that in lateral direction, whatever the strain is going to be sigma 3. If I say undrained condition, the meaning of undrained is change in volume is going to be 0. Then the strain will be is equals to 0. So whatever the direction, in this direction, first of all, you see, due to sigma 3 in this direction, see, I want in this direction the strain, right? So the stress is going to be sigma 3. In this direction, the strain is going to be that stress by Young's modulus. Now, coming to this one, for sigma 1, this is a longitudinal, this is going to be lateral. For sigma 1, longitudinal, and this is going to be lateral. What is the lateral strain? Minus Poisson's ratio into what is the longitudinal strain? Sigma 1 by E. Similarly, for sigma 2, this is going to be the longitudinal and this is going to be the lateral. So what is the lateral strain? Minus mu into longitudinal, sigma 2 by E. You know that mu is nothing but minus lateral by longitudinal. So lateral strain is equals to minus mu into longitudinal strain. So now this should be is equals to 0. So then sigma 3 minus mu into sigma 1 minus mu into sigma 2 is equals to 0. As you know, sigma 2 is equals to sigma 3. I can write that Sigma 3 is equals to, let's take it outside, sigma 1 plus sigma 3, and mu is equals to sigma 3 by sigma 1 plus sigma 3. If you would have completed the strength of materials, then it would have been much more easier, but don't worry, I have given you this condition, right? Similarly, you can write anywhere. See, sir, what is the strain in vertical direction, sir? You can write that. What is E1 now? In the E1, you can write in the direction sigma 1 by E. In the lateral direction, minus sigma 3 by E minus mu into sigma 2 by E. You can write this one also. But I am taking the lateral direction, not the vertical direction. I hope you understood this. Now let's solve the classroom practice questions. So with all these conditions, now I am going for the classroom practice questions. In CD test, there is a granular soil whose permeability high. So water will dissipate quick now. So it should be short-term stability. Yes. Who said the CD is long-term? I said as, oh, okay, it should be a short-term stability. Arre baba, water will definitely take, but immediately, short-term means immediately after the construction. Do you think the water is going to dissipate? Immediately will it dissipate? No, right? It will take some time. Immediate means, short-term means immediately after the construction. Immediately after the construction, entire pressure will be taken by water. If it is a clay, it will take very, very long time. It will take, if it is a sand, it will take some time, but it is not going to be dissipate immediately. Okay, fine. Now, give me a minute. Foundation engineering will start from tomorrow onwards. So we are almost about to end the shear strength, but some topics are there. I don't think it will be complete today, but tomorrow in first 1 hour, we'll be completing the shear strength, and then we are going to discuss about the foundation engineering. From tomorrow onwards, the foundation engineering would be there. So now you see this question. These are classroom practice questions. So far I discussed about the previous GATE and IES questions. So now I'm discussing the classroom practice questions. What about stability of slopes? Stability of slopes means a foundation engineering, my dear darling. So up to strength of, up to the shear strength, the soil mechanics, and whatever the chapters we are going to discuss beyond the shear strength, there is a foundation engineering. Foundation engineering means stability of slopes, earth pressure theories. I have given you the chapters earlier, so you can please go through that once again. Now, a soil sample is tested under a direct stress of 5 kg per centimeter square. The meaning of direct stress means vertical stress, and all round stress sigma 3 is equals to sigma c, which is going to be 3.2 kg per centimeter square. So if this is an element, what is the total direct stress? Direct means vertical, sigma 1 5, and sigma 3 is going to be 3.2. Now, if the shear stress on the failure is 0.9 kg per centimeter square, what is the angle of internal friction? See, I'll solve this question in 2 ways. Listen to me carefully. I'll solve this question in 2 ways. First, let me go with the conventional way. See, if this is an action, then this is going to be the shear failure. And what about this one? Alpha. Now, you know, when a soil element is subjected to major and minor principal stress, what is tau? Tau means sigma 1 minus sigma 3 by 2 sine 2 alpha. I hope everybody knows this one. And when it is a failure, then tau becomes tau f, alpha becomes alpha f. Yes or no? Yes. See, they have given these details and they're asking you phi value. They're asking you phi value. So now tau f is equals to sigma 1 minus sigma 3 by 2 sine 2 alpha f. What is tau f? 0.9. Sigma 1, 5 minus 3.2 by 2 sine 2 alpha f. And you see 5 minus 3.2, 1.8. 5 minus 3.2, 1.8 by 2, 0.9. This entire value will get cancelled. Sine 2 alpha is equals to 1. And from this, can I write 2 alpha is equals to 90 degrees? 2 alpha is equals to 90 degrees. And what is alpha f then? Alpha f is equals to 45 degrees. You know that alpha f means 45 plus pi by 2. What is meant by alpha f? Angle made by the failure plane with respect to major principal plane. Now, if it is going to be 45 degrees, what is phi value? Phi is equals to 0 degrees. So, what is the answer? Phi is equals to 0 degrees. See, this is a conventional procedure. I gave you direct stress as a major and all-round stress means a side stresses. All-round means side stresses, not the vertical stress. So sigma 3 is equals to sigma c is equals to 3.2 kg per centimeter square. Yes. Logic. You see the logic? Mohr circle. I'll draw the Mohr circle. Logic is always with the Mohr circle. Have a look, everybody. What is sigma 3? 3.2. What is sigma 1? 5. Then if I draw the Mohr circle, then what is the center? The center is nothing but the radius is going to be sigma 1 minus sigma 3 by 2, 5 minus 3.2 by 2, which is going to be 0.9. Yes or no? Which means if this value is going to be 0.9, this value is also going to be 0.9 or not. Then tau is 0 degrees. I gave you that when tau f is equals to tau maximum. When tau f is equals to tau maximum. Yes. When tau f is equals to tau maximum, phi is equals to 0 degrees. See, the logic is as simple as that. I know the tau maximum. What is tau maximum here? Radius. Yes or no? And you know that when the tau maximum and this value both are going to be same, then this is going to be the failure point or not? Yes. And if that is the failure point, you know, always failure envelope should be tangent to the Mohr circle. If this is the failure point, what is the tangent? This is the tangent. Then phi is equals to 0 degrees. So that's the logic. You can go with the basic procedure. This is a basic procedure. And this is going to be the logical way of explanation. If you can understand the logical way, you can understand the concept much more easy. Because I don't want to use the equations directly. I know from where I derived these equations. From where? From the Mohr circle. Okay. So I hope you understood this question. This is question number 1. Yes. Sir, sigma 1 should be direct plus confined now. Arre Baba, my dear student, the meaning of the direct means total vertical stress. The meaning of direct means total vertical stress, not it is a vertical means 5 plus 3.2. No, the meaning of total direct means whatever the stress in the vertical direction, that is a direct stress. And the logic is simple. You draw the Mohr circle. Once you draw the Mohr circle, what is this value, please? This is 0.9. which is equals to tau f, yes or no? And when the tau f means this is the failure point. So once it is a failure point, now look, if this is a failure point, failure envelope should pass us through that and as a tangent. This is one line, tangent. So when you draw the tangent, what is the phi value? 0 degrees. Now let's see the question number 6, because this question number 4 and 5. Now you please solve this question number 5. I'm giving you 2 minutes of your time. I'm giving you 2 minutes of your time. I'm all asking you, you see, observe this question. This is classroom practice questions. All these are classroom practice questions. So can you please solve this? 2 minutes. First of all, what is a test? CD test. What is the type of soil? NCC. When the test is going to be CD test and the soil is going to be NCC, then you know that C is equals to 0 and phi is equals to sine inverse of major minus minor by major plus minor. Come on, solve that. I'm giving you 2 minutes of the time. I'm asking you to solve these values. Come on, solve. I hope you people will be able to solve this. Come on. I'm giving you time to solve this. Look the question carefully. Angle which the failure plane makes with the major principal plane, which means they're asking alpha F. And what are the normal stress and shear stress on that failure plane? They're asking that also. The first one should be 55.4 degrees or 55.39 degrees. $55.39. You see, now you observe. See, first of all, by seeing the question, you need to look over, is it what type of test? CD. What type of soil? NCC. Then which is 0? C0. Then what is phi? Sine inverse. So now, first of all, find out the sigma 3. What is sigma 3? 250 kilopascals. And what about sigma 1? Sigma 3 plus sigma D at failure. 250 plus 275, which is going to be 525 kilopascals. So now phi is nothing but sine inverse of 525 minus 250 by 525 plus 250. So if you solve, you will be end up this value as a you will be end up this value as 20.78 degrees. And what is alpha f? 45 plus 5 by 2. 45 plus 20.78 by 2, which is going to be 55.391 degrees. So if they ask you 2 decimals, generally we take it as a through 2 decimals. If they ask you 2 decimals, 55.39. If they ask 1 decimal, 55.4 degrees. Or I can solve the same thing from plastic equilibrium equation also. See, this is the logic, right? Now, from plastic equilibrium equation, this is method 1. This is a logic, right? This is a logic and this is the basic. From the plastic equilibrium equation, sigma 1 is equals to sigma 3 tan square alpha f plus 2c tan alpha f. As you know, c is equals to 0, then sigma 1 is equals to sigma 3 tan square alpha f. From this, tan alpha f is equals to root of sigma 1 is how much? 525 by 250. So from this, what is the alpha value? You can directly find it out. 525 by 250 square root, and the value should be tan inverse. Then it is going to be 55.39 degrees. See, either you go for the logic or you go for the basic. See, here they're asking alpha f, right? Then this would be easier. Then if they ask only phi, then with single step you can find out these values. I hope you are clearly observing what I'm doing over here. Now, if this is the plane, you please observe. So what is the meaning of this one is, I apply sigma 1 as 525 kilopascals and I apply sigma 3 as 250 kilopascals. You have applied this one. And from the details what we got to know, if this is a failure plane and this failure plane is going to be making an angle alpha f. So what is the alpha f we got? 55.39 degrees. This is the question I asked. Now, what is the next question? Arey sir, if that is the case, what is the normal stress and shear stress acting on the failure plane? The normal stress and shear stress, this is going to be the failure plane or not? And shear stress. So first, how to find out the normal stress and shear stress? Normal stress means sigma 1 minus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos 2 alpha, and alpha becomes alpha f. So 525 plus 250 by 2 plus 525 minus 250 by 2 cos 2 alpha 55.39 degrees. Come on, please tell me this sigma value. 525 minus 250 by 2 into cos of 2 into 55.39 and 525 minus 48.78. So I hope so the value is going to be somewhere 338.72 kilopascals. I hope you people got the same value. So yes. Sir, in this question they have given delta sigma. What delta sigma D means? What is the increase in additional stress? You have to take it as what is meant by D sigma D? Additional stress only, right? How much I have increased is 275. So you are adding that one, yes. And now, what about the tau, sir? Tau F is nothing but sigma 1 minus sigma 3 by 2 sine 2 alpha F. So what is sigma 1? 525 minus 250 by 2 into sine 2 into 55.39 degrees. Now, tau F is nothing but into what is sigma D they have given 275 by 2. I hope everybody got the tau F as 128.55 kilopascals. 128.55 kilopascals. Or I can write one more way also. What is that way, sir? Sir, you know, sir, what is the failure shear stress, sir? Which is nothing but shear strength, sir. S is equals to C plus sigma into tan phi. C plus sigma into tan phi. I mentioned it clearly in the question. C is equals to 0. Then what is S? What is sigma? 338.72 into what is tan? Phi value I got 20.78. So what is the shear strength you are going to get? Please tell me. Tan 20.78 into 338.72. So I hope you got the same value as 128.53 kilopascals. Everybody, yesterday I have discussed one question, right? There I asked you first to find out the normal stress and shear stress, and then I asked you failure plane also. Now in this question I am asking you, first, if this is a test conducted on NCC, what is the angle made by the failure plane? We got it as 55.39. And if this is a 55.39, what is the normal stress and shear stress acting on the plane? First I went with the formulas, or I can find out that tau F, you know the failure shear stress is nothing but the shear strength, right? Then C is going to be 0. When C is going to be 0, sigma into tan phi. Whatever the sigma, 338.72 into tan 20.78, you're going to get the same shear strength value. I hope you understood this condition. So now that's all, my dears. So this question, I hope you understood this very well. Please let me know. Now you please let me know, does the topics are clear for you or still problem for you? I hope it's been easy for you people. So just simply the logics for solving the numericals, the logics, that's it. I'm not going too much of equations over here. Now, you see, I'm giving you this question number 6 as a homework for you. This is a question number 6 as a homework for you, because everybody have a look about this one question. Again, what is this test? CU test. And what is the soil? NCC. Then which is going to be 0? In the case of NCC, which is going to be 0? C is equals to 0. Sir, now you see they have given the consolidated under stress sigma C. What is sigma C? 200. Deviating stress at failure 150. Pore water pressure is given as 75 kilonewton per meter square. Determine analytically the shear strength parameters both in terms of total and effective stresses. You see C0, they're asking phi u and they're asking phi dash. See, I solved this similar type of question in GATE 2017. Yes or no? You know that. See, the point is when they give the question, first of all, give me a minute once. Yes. So when they give you a question, first of all, you need to look over the test. And what is the type of soil? NCC. And I have explained you the results. So from there, C is equals to 0. So don't ask me, sir, why you are taking the value as C0, sir, because I have given you here clearly CU test. So in the case of NCC, C0 means phi dash and phi u would be there. You know what to solve. For phi u, sine inverse of sigma 1, and I'm not going to discuss this because I'll be leaving you for the homework. I'll see how many of you will solve this question, because the similar type of question I have been explained. Let me show you that question once. Yes, you see this question, GATE 2017. There they're asking effective angle, and I have solved the effective angle, and I have solved the total stress also. So this is a question. Please refer GATE 2017 if you don't get a answers. So model of GATE 2017. You please go through this and you can find it down. I hope you understood these questions pretty clear. Now, if you understood, let me go for the next topic. So whatever we have been discussed is nothing but triaxial shear test. So we completed the direct shear test and we completed the triaxial shear test. Now, types of failures in triaxial test. Types of failures in the case of the triaxial test. So what are the type of failures we are going to see in the case of the triaxial shear test is there are 3 types of failures. Brittle failure, plastic or progressive failure, semi brittle or semi plastic failure. See, we have solved these values, right? Now you know when the failure is going to be happen. You please look over here. Yes. What is the point I mentioned over here? Note down the deviating stress at which shear failure is going to be happen. Yes or no? And now how does the shear failure is going to be happen for different type of soils? In the case of different type of soils, what is the type of failure we can see? Now, if you see in the case of the brittle failure, brittle means sudden failure. You know that brittle means sudden failure. Sir, when does this is going to be happen, sir? Sir, brittle failure occurs in the case of dense sands and over consolidated clays. Why, sir? Sir, in the case of the dense sands, already strength is more. Yes or no? And now, when there is a shearing, what happens? In dense sands, I told you clearly day before yesterday, interlocking between the particles will fail. When the interlocking fails, then soil will shear easily. So now, if I represent that, you see, whatever the soil element will fail with a clear failure plane, well-defined failure plane would be there. So this is a soil element, and whatever I'm showing you over here, this is nothing but a clear failure plane. This is a failure plane, which means I can say this is well defined failure. Well defined failure, and it occurs at low strengths. Sir, why low strengths, sir? Sir, in the case of dense sand and OCC, already strength is more, sir. Sir, now, sir, if you look over this, sir, in the case of dense sand, sir, gets sheared. Initially, it undergoes compression and later interlocking between particles breaks. And immediately the soil will be sheared with what type of failures? The type of failure is a brittle failure. And now this is generally seen in dense sands and over consolidated clays. Now coming to the progressive failure. Progressive failure or plastic failure. Here what happens is, first, initially this is the soil element. Now, initially this is the soil element. In the case of the plastic failure, what happens is during shearing, at first due to compression, soil will undergo compression like this. And during shearing, the lateral bulging would be takes place in this fashion. Lateral bulging would be takes place in this fashion. So this type of failure is known as a plastic failure. If there is a well-defined failure, now you see the same soil mass. Now this is initial, and upon loading and shearing, the soil will fail like this. And it will be happen in the case of loose sands and normally consolidated clays. So in the case of loose sands, volume will undergo compression, then the strains are going to be more. And moreover that the lateral bulking would be happening or bulging would be happening. Failure occurs at large strain with lateral bulging with lateral bulging. See, this is nothing but bulging, and these type of failures seen in loose sands and NCC, loose sands and NCC. So now this is going to be the plastic failure. One extreme is going to be dense sands, so their clear failure would be there. In the case of the loose sands and NCC, they can undergo more compression, so that is going to be the plastic failure. And now last one is semi-brittle or semi-plastic. There you can see both the brittle nature and the plastic nature. So in this case, I'm just representing directly the element. Not only the bulging, but also these are going to be the cracks. So bulging would be there, and these are going to be the cracks, shear cracks would be there. So if there is a bulging and cracks, then you are going to call it as a semi-brittle or semi-plastic failure. Medium strains. See, you don't need to worry about the values. Generally, for the brittle failure, the strain is going to be some 4 to 6% of the strain, and here 10 to 15% of the strain. And in between is going to be the medium strains. So seen in medium sands and clays. Seen in medium sands and clays. So dense sands and OCC, you can say it as a plastic, sorry, brittle. Loose sand and NCC, you can say it as a plastic. And if the denseness of the soil mass is medium, then you can guess as a semi-brittle or semi-plastic nature. So with this, I have covered every topic regarding to the triaxial shear test. Today, we have been discussed these things. And one more thing. One more thing, I'm going to provide the assignment for chapter number 11 and chapter number 12 today. Today, I'm going to give you chapter number 11 and chapter number 12. And you please go through the chapter number 13 now. And tomorrow, I'm going to provide the assignment for chapter number 13 also. Now, the next test is, see, done with this chapter already, everything completed. Now, the next test is going to be unconfined compressive test. Now everybody have a look. Unconfined compressive test. See, this is exactly same as the triaxial shear test. You can call it as a UCS test, which means unconfined compressive strength test. Listen to me carefully. What is the difference between that shear test and this UCS test, sir, is what is the meaning of confining pressure? Sigma C, yes or no? Now, the meaning of unconfined is, see, the confining pressure is due to whom? Water present in the cell. So now, if there is a water, there is a confining pressure. Now, in the case of UCS test, I take the same test apparatus, but I don't fill with water, which means I can say this is a special condition of triaxial test with no confining pressure. With no confining pressure. What is the meaning of no confining pressure? Sigma C is equals to 0. That's it. And you know what is the meaning of sigma C is equals to 0? You know, this is nothing but sigma 1, which is going to be sigma C plus sigma D. And you know, this is nothing but sigma C. Sorry, sigma 3 is equals to sigma C. So if I say no confining pressure, then sigma C is equals to 0. So which means I don't need to worry about any stress laterally. And whatever the stress acting on the element, the major principal stress is nothing but the deviatoric stress only. So here, as sigma 3 is equals to sigma C is equals to 0, and sigma 1 is equals to sigma C plus sigma D. So sigma 1 is equals to sigma D. Now I am going to write this one as QU. So now you tell me, this is same as the unconfined. The unconfined compression test is the same as the triaxial test. But what is the only one condition we are applying here is confining pressure. When there is no confining pressure, sigma C is equals to 0. When there is no confining pressure, sigma C is equals to 0. And when sigma C is equals to 0, then sigma 1 is equals to sigma D. Now, I am going to write this as QU, which is known as unconfined compressive strength. Sir, why you are calling as an unconfined compressive strength, sir? Because there is no confining pressure. And moreover that, what is the nature here? Compressive or tensile? Compressive in nature. So due to this compressive in nature, and there is no unconfined compressive strength. Now, in this condition, in this test, rate of loading is going to be quick. So you know that when the rate of loading is going to be quicker, what's the type of test it is? You see, when the rate of loading is going to be quick, what's the type of test? Undrained condition. So in this test, rate of loading is going to be quicker. We call it as undrained test. Mind it, unconfined compression test is a type of undrained test. Now, from plastic equilibrium condition, in this test, rate of loading is going to be quick. So from plastic equilibrium condition, sigma 1 is equals to sigma 3 tan square alpha F plus 2C tan alpha F. Okay, now apply the conditions, please, my dear. If you apply the condition, you know that sigma 3 is equals to 0. When sigma 3 is equals to 0, and what is sigma 1? This is known as QU. From this, I can write QU is nothing but C, 2C, undrained, right? Undrained means U. What is the meaning of undrained? The total stress analysis. And whatever the parameters are CU and phi U. So 2 times of CU tan alpha F. Tan alpha F. Now, this is the equation. But generally, undrained test is conducted on clays. Yes or no? If there is an undrained test conducted on clays, now you please tell me phi u is equals to 0 in the clays. Then tan alpha F is equals to when phi u is equals to 0, then alpha F is equals to 45 plus pi by 2, which is going to be 45 degrees. Then QU is equals to 2 times of CU. So now you tell me what is the final equation we got? QU is equals to 2 times of CU. Mind it, my dear students, I am asking you again, the QU is going to be 2 times of CU when the soil is going to be clay. And if they give you some other soil mass, then you have to apply this equation. QU is equals to 2CU tan alpha F. Just simply, this is a condition, Nana. This is not even a test also actually. This is a special condition on the triaxial test. That's it. Where QU is known as unconfined compression test. And now from that QU, I can write CU is equals to QU by 2. So now you see, observe one more thing over here. You know that this CU is known as undrained cohesion. Undrained cohesion. C dash drained, CU undrained cohesion are undrained shear strength. Sir, how come you say it as a shear strength, sir? Now let's see, sir. Sir, what is the shear strength equation? Cu plus sigma into tan phi u. Keep in your mind, what is the test I am using? Undrained test, which means total stress analysis. Now, as I told you, in the case of the clays, in clays, you know that phi u is equals to 0. Then what is S? S is nothing but Cu. So when S is nothing but Cu, can I call it as a Cu is nothing but undrained shear strength. So why I call Cu as undrained shear strength means, in the case of undrained test, and if it conducts on a clay soil, phi is going to be 0, then the shear strength is nothing but the Cu value. And that Cu can be called as a strength. Which condition? Undrained shear strength. So the note point over here is in clays, you observe what is Qu? Undrained, unconfined compressive strength. And what is Cu? I got undrained shear strength. In clays, undrained shear strength is half of unconfined compressive strength. Unconfined compressive strength. Undrained shear strength is half of unconfined compressive strength. So that's about this test. See, if you observe clearly, I have not done much of concept over here. What I done is sigma C0, I applied, and 1 over this rate of loading is quick. So total stress analysis by applying QU is equals to 2CU tan alpha F and QU is equals to 2CU. And if I draw a Mohr circle for this, if I draw the Mohr circle for this, then please look over. If I draw a Mohr circle for this, now this is going to be, let's say, so you please let me know. In this case, what is sigma 3? Sigma 3 is equals to 0 and sigma 1 is equals to sigma d is equals to Qu. Yes. So now sigma 3 is going to be 0 and sigma 1 is equals to Qu. So now if I draw a Mohr circle, so this is going to be the Mohr circle, and you know it very well. When sigma 3 is going to be 0, the Mohr circle will touch us with the origin. The Mohr circle will touch us with the origin. So now this is sigma 3 is equals to 0 and sigma 1 is equals to Qu. And moreover that, in the case of clays, you know phi is equals to 0, right? What is the meaning of phi 0? See, I draw the Mohr circle, that's fine. But in the case of clays, I told you phi is equals to 0. What is the meaning of phi is equals to 0? So phi 0 means the failure envelope 50 means the failure envelope is going to be horizontal, which means phi u is equals to 0. Then whatever this is nothing but the CU. This is known as CU. Yes. And you know, whatever this difference is going to be sigma 1 minus sigma 3 by 2, which is going to be QU by 2. And whatever this value is also going to be QU by 2. From this, CU is equals to QU by 2 or QU is equals to 2 times of CU. See, just directly the logical explanation for the unconfined compression test in the case of clays. The logical explanation, that's it. I know sigma 3 0 and sigma 1 is equals to sigma d is equals to QU. So from this I can write directly phi 0 for the clays. In the case of clays, phi 0. So I hope you understood this clearly. Yes, more circuit will exist in practical. Sir, why we use hydrostatic pressure? Is there another way of confining pressure? No, Nana. If you want to apply all round pressure, that should be hydrostatic pressure only. Now, you please look over here. So now, the point over here is I need to find out the note. Yeah. So I hope you understood the conditions over here. QU is equals to 2 times of CU. There is a one more condition we need to mention here. Note. Initial when you apply the load, this was the element. When you apply the load, this was the element, which means when you applied sigma d, which is going to be QU, this was the element. Now, due to this, yet failure, you can observe the soil condition would be somewhat like this. And you know, if the soil condition is going to be this failure, I told you the failures over here, then I can say it as a plastic failure. Now, yet a failure, this is going to be sigma d at failure. So this is just a small application, and this is going to be sigma d at failure. This is going to be QU. This is actual area. This is the actual length of the element. See, mind it. Let's go to the figure. Whatever the load I am applying, you please observe what is this deviatric stress. The deviatric stress, to apply the deviatric stress, we are going to apply a load. Yes or no? Stress means load by area. Yes. Now, I am going to find out the stress at the failure as a sigma df. Now, at the failure, sigma df is nothing but QU. But what is the failure over here? This is going to be AF, which is nothing but area at failure. What I want to say to you is, students, when the soil is going to be failed, you know the soil will undergo some deformations. Yes or no? Don't say no. And second thing is, and when it gets deformed, the area is not going to be same as earlier area. So you need to find out the area at failure. So now, you see, whatever the area at failure, QU is nothing but whatever the load you applied by AF, which means area at failure. Sir, how come I find out the area at failure, sir? Normally, area A is equals to volume V by length as L. So which means area is equals to V by L. Now observe carefully. When I say this is going to be at failure, now you go back. Due to this swelling, due to this side swelling, the volume may increase or decrease. It depends upon the type of soil. You know that clearly. You know that clearly. It depends upon the type of soil mass. So the volume may be increases or decreases. When the volume decreases, in the case of the loose sands, volume will decrease. Delta V is negative. And in the case of the dense sands, I told you in dense sands, the soil will undergo dilation. If you have any doubt, you please go through the previous details. I have explained you every point over here. In the case of dense sand, dilation, volume increase, delta V positive. And in the case of loose sand, compression, soil volume will decrease. So now, and if you see the length will be under compression or not. So definitely the length will be decreases. So L minus delta L. This is the area at failure. But now in UCS test, it is an undrained test. What is the meaning of undrained test? No expulsion of water. When there is no expulsion of water, then delta V is equals to 0. So change in volume is going to be 0. So now if I apply this condition, the area at failure is nothing but volume by L minus delta L. Uniaxial and UCS both are same. Yes. So now area at failure is nothing but what is volume? Volume means, see, you see the initial volume. What is V? Initial volume. What is initial volume? Initial volume means area into length by L minus delta L. Then AF is nothing but A by 1 minus delta L by L. And area at failure is nothing but A by 1 minus strain. What is this strain? This is going to be longitudinal strain. Longitudinal strain, or you can write as axial strain. So what is the axial strain over here? Delta L by L. So in the case of finding the deviatoric stress or unconfined compressive strength, the load P by area at failure, you have to take the area as area at failure, not the actual area. And how to find out the area at failure? This is the condition. So in UCS test, as you know, undrained test, which means no expulsion of water, the change in volume of water is going to be 0. So the area at failure is going to be A by 1 minus longitudinal strain. Now, let's see this question. Let's see this question first. In an unconfined compression test, which means UCS test. See, finally, what the points you need to remember here is how to find out the area at failure and what is the unconfined compressive strength normally and what is the unconfined compressive strength in the case of clays. Now, see, they mentioned the clay. In a confined, in a UCS test, the soil is going to be clay. Then what is the length over here? I have given as 100 mm and dia D is going to be 50 mm. Fails under a load of 150 newtons. So if you take the element and on that element you applied a load at failure, which is nothing but 150 newtons. And what is the strain over here? 10%. What is the strain over here? 10%. Calculate the shearing resistance taking into the account the effect of change in cross section of the sample. So what they mentioned is you need to consider the change in cross section. Now, as you know, in the case of clays, in UCS test, QU is nothing but 2Cu. But what they're asking the shearing resistance. What is the meaning of shearing resistance? The shearing resistance means shear strength. So they're asking the Cu value. Now you see, this is nothing but Cu. They're asking Cu. What is Cu? Cu means Qu by 2. But first of all, you need to find out the Qu or not. See, I'm telling you again, the test is going to be UCS test and soil is on clay. So as it is clay, Qu is equals to 2 times of Cu. Whether they are asking unconfined compressive strength or shear strength. Shear strength means a shearing resistance, which is nothing but Cu. So for that, you need to find out Qu. What is Qu? Qu means load at failure by area at failure. Area at failure means 1 by 1 minus strength. Yes. So can you please find out this area? Pi by 4 d square into 1 minus strength. So area at failure is equals to pi by 4 into, see 50 mm means, so they are taking in terms of newtons only now. So find 50 mm, you tell me first of all. 50 square by 1 minus strain as 0.1. Can you please tell me the value of area? Pi by 4 into 50 square by 0.9, which is going to be 2181.66 mm square. So now from this, you know that Qu is equals to, what is the load? 150 by 2181.66. See, what are the units over here, please? Newton per mm square. Okay. Now, can I convert these units as, everybody have a look? What is a 1 mm square? 1 mm square is nothing but 10 to the power of 6 meter square. Yes or no? 1 mm square is nothing but 10 to the power of minus 6 meter square. So then if I take to the numerator, then it is going to be 10 to the power of 6 meter square, which means Newton per meter square. So you please find it this value. 150 into 10 to the power of 3 by 2181.66, which is going to be 68.754 into 10 to the power of 3 newtons, which means I can write as kilonewtons. Can I? So I'm just converting the units. I can write this one as 2181.66 into 10 to the power of minus 6 meter square. Apply over here. It will go to the numerator. And what is 10 to the power of 3 newtons? Kilonewtons. Then finally, what is Cu value? Cu means 68.754 by 2, which is going to be 34.377 kilopascals. If I round it to 2 decimals, 34.38 kilopascals, rounded to 2 decimals. I hope you understood the meaning over here. The point that you need to know here is area at failure. They clearly mentioned account the change, effect of the change. They have asked account the effect of the change in the cross section. So when they give you account the change in cross section strain, you have to take the area as area at failure. I hope you understood it clearly. And the last question for today's class, one more question I'll solve, and with that I'll conclude this, because I want to solve the question based upon the UCS only. A small question only, that's a previous GATE and IES. Now why I want to solve now itself is I want to show you what is the problem that you are going to face here. Now again the test is going to be which test? Unconfined compression test is conducted on a cylinder of a soil. Now understand here, did they mention the soil is clay? No. Now it fails under an axial stress. What is the meaning of axial stress? The total vertical stress. The axial stress sigma 1 is equals to, it fails at what stress? 120 kilonewton per meter square. Okay. Yeah. The failure plane makes an angle of 50 degrees. This is the failure plane makes an angle of 50 degrees with respect to horizontal, which means alpha f is given as a 50 degrees. What the students do the mistake most is immediately while you are studying, what you do is array sir, the UCS test sir, UCS test means QU is equals to 2 times of CU na sir. So if you apply 2 times of CU directly, go with the yes. Okay, where is the question? Yes. So if you apply QU is equals to 2CU directly, then you know QU is nothing but 120. Then what is CU? They're asking cohesion, right? 120 by 2, which is going to be 60. Yes, there is an answer. But if you keep it, you will be out of coverage area. Why, sir? Sir, this is for whom, sir? This is for clays. Did I mention anything for clay, sir? No, sir. In the case of clay, phi is equals to 0, sir. Yes, sir. But I have given you the alpha f or not. When I give the alpha f, how come you take the phi value as 0? That's the mistake most of the students do. See, while you are reading the question, you need to read the question clearly. If you see the previous question, in this question, I mentioned the soil. What is the soil over here? Clay. The clay is there. So I mentioned the question clearly, the soil is clay. But you see this question, did they mention the soil is clay? No, which means this is not going to be true. So now when alpha f is going to be 45, alpha f means 45 plus 5 by 2, which is going to be 50 degrees. Then what is phi value? 50 minus 45, 5 into 2, 10 degrees. So the answer is going to be 10 degrees. They will give you 0 also. This 0 will give you to make you 0. And not only 0, they will take you some marks from you, which means you will get the negative mark also. So my dear students, be careful regarding to this UCS test. I'm telling you again, if the soil is clay, QU is equals to 2CU. And if they give any soil, then QU is equals to 2CU tan alpha F. You remember this one. And if it's a clay, phi 0, alpha F is 45 degrees. So now you tell me, what is the QU? 120 is equals to 2 into CU into tan 50 degrees. Find out the CU value, please. 60 by tan 50. So which is going to be some 50.34 kilopascals. The nearest value is going to be 50 kilopascals from options. So the answer is going to be 50, not 60. I hope you understood what is the logic behind over here. So don't fall into these type of pitfalls, because I am going to give the questions like this manner only. I'll give you the questions very small changes. So while you are reading the question, be careful about what you are reading. Today I have been discussed about a lot of things regarding the triaxial test. I'm telling you, this chapter is very important for both the IES and GATE. So if you neglect this chapter, I'm telling you, you can you are not going to get good marks in the examination. So throughout the problems, I have fundamentals. I have some fundamental. What is that fundamental? I'm going to go for this one. The remaining questions will be solved tomorrow. Throughout these results, I am applying these results only. That's the reason why I kept too many star marks. What is the result? Soil NCC, C0, 5. And soil UU, which is nothing but any soil mass you take, phi is going to be 0, then C is going to be tau max, sigma 1 minus sigma 3 by 2. Some of the people are asking, sir, what is sigma D, sir? Arre Baba, sigma D. Sigma 1 is nothing but sigma plus sigma D R na. Then what is sigma D? Sigma 1 minus sigma 3. So I hope you understood today's class. So these are the things we discussed today: triaxial shear test, procedure, and how to plot the graph, and what are the drainage conditions, what are the tests, and where you are going to use this test practically. And then I gave you the results from the triaxial shear test, and then I discussed about the type of failures, and then unconfined compression test. So what is unconfined compression test? How to determine the means unconfined compression strength. So we have done some problems, some classroom practice questions. I gave you this as homework. Please go through it as homework. This is a homework for you. And this is a classroom practice question. So some questions are left over and we'll see those questions tomorrow. So we have solved a lot of IES questions and a lot of gate questions. So this is a gate questions and I solved these questions. Remaining questions will be solved for tomorrow's class, means tomorrow whatever the topics we are going to discuss. Yes, I hope. See, this is also homework for you. This is ESC 2015. I'm going to show you this question also. So I'll be adding these slides for you. Whatever the PDF I'm going to give to you, you please open the PDF. Now it's 1:17. I'll be uploading the PDF before 2 or 2 o'clock. By 2 or 2:10, I'll be uploading the PDF. So you open the PDF, I'll be attaching this homework also. So please keep that in your mind. That's all. The values. How sigma d fail is equals to QU, sir. So foundation engineering, it will take some time, sir. Foundation engineering may take 25 to 30 hours, which means one week more. Now it's 2:26. So we'll be having classes for the next 7 to 10 days. We'll be finishing those. And now those who wants to leave, they can leave. Already people have left also. Sir, which is easier in the level of questions, ESC or GATE? Both, if you ask me. So will the syllabus will be completed in October? No, it won't exit till November now. See, right now the situations you see, you know the situations right now. You never know what happens next. So forget about the future thinking. Right now you focus on the present. I don't have any idea on the next subject. I'm sorry for that. See, NCC and sand, that's not sand, that's loose sand. The shear characteristics are same, but not the other characteristics. Don't think about that. I don't know, day by day, the people you attending the class are reducing. So tomorrow, new chapter. Yes, in the first 1 hour, we have to solve the questions and then we'll be go for the next one. So now I'll be taking a I'm activating. So I activated the raise a hand option. So now I'll be discussing the doubts. See some of the students. Sir, how many marks for GT in GATE? Is there any second chance of announcing lockdown against the second wave of virus? We don't know, but we can expect that. Please upload recorded videos as soon as possible, sir. It has been uploaded at 10:30 p.m. at night. See, my dear student, see, you have to look over a large view. Right now, all the classes were going on in mechanical, civil, CSE, and electrical. So the people who are working there also, they are working to late nights. And the people who are doing this technical work regarding to this recording sessions and taking corrections, it's not as simple as that. They have to edit a lot during the recorded sessions. They're taking too much of time. And during the lockdown sessions also, they are away from their homes and they are in the offices. They're staying there, they're living there, they're eating there itself, and they're doing continuous work. So why they are sending at 10:30 means By evening 8:30, all the sessions would be completed. Then they are going to be probably to solve, means to send all the recorded sessions. So that's the reason why I am sending the PDFs for you, right? You have listened the class, right? See, I'm not giving you the PDF directly onto your face. I'm saying each and every point clearly, and I am giving you the PDF. Please go through the notes once. Think about that. At what time you sleep daily because you are too busy with works? I don't know at what time I sleep. Yesterday I slept around 2 or 2:30, and day before yesterday I slept at 3 o'clock. And I don't have a peculiar timing, so I don't follow like 8 hours per day sleep. So the people who are sleeping 8 hours per day, they are wasting 1/3 of their time in their lifetime. 1/3 of your lifetime. If you want to live for 100 years, you are wasting 33 years of your lifetime for the sleep itself. So I don't give much preference for the sleep, but I do sleep. I don't say I don't sleep. I do sleep, but it's not like a regular cycle. Yeah, so my dear students who are raising their hands, Mr. Sachin, speak out.
Hello, sir.
Mr. Sachin, please speak out.
Hello, sir.
Yeah, Sachin, please raise your voice. I'm not able to audible to your voice.
Can you hear me?
Yeah,
Hello?
I hear you. Yeah, I hear you.
Sir, does alien soil has low density and low compressibility?
Yes, low density and high compressibility, not low compressibility. Low
Okay.
density is going to be less, then compressibility is more.
Okay, sir. Sir, another doubt, sir.
Yes.
Sir, in ESE peak previous year question chapter 2, can you please take the PDF, sir?
Give me a minute.
Okay, sir.
Is it able to see this for you?
Sir, I can't see that, sir.
Okay, fine. Don't worry.
Okay, sir.
Now?
No, sir.
Are you able to see this one? Whatever I'm showing you some white PDF.
Yes, sir. Why PDF is visible, sir?
Yeah.
I asked ESE previous year question PDF, sir.
ESE previous year question. I think it is not opening. Give me a minute. I will go through once again.
Okay, sir.
Now I hope it is visible to you.
Yes, sir. In
Chapter number
chapter 2, question number 19, sir.
Ray, you are asking chapter number 2 now. Huh?
One simple, small doubt. Question number 19, yes, sir. Sir, I want clarification in the reason, sir.
The free water, absorbed water, and structural water are completely removed from the soil by heating it at 105 degrees centigrade. See, free water and absorbed removed it up to 110 degrees centigrade. Okay.
Okay,
But
sir.
to remove the structural water, you need to increase the temperature more than 110 degrees centigrade.
Okay, sir.
The structural water is going to be removed, and the crystalline structure will break and soil will break down.
Okay,
So,
sir.
it is not to remove the structural water, remove only free water and hygroscopic water, means like a capillary water and all those things. Understood? We
Okay,
don't
sir.
the structural water. So beyond the temperature 105 to 110 degrees is only for the free water and capillary water and all those things, not for the structural water. Okay.
Yes, sir. Sir, another doubt, sir.
Yes.
Sir, in the 32nd question, sir.
In this chapter only.
Yes, sir. Yes, sir.
Second question.
30 seconds. 3 to 30 seconds.
What's the problem there?
Sir,
Sevak.
yes, sir. Say I used Sevak, sir, but I am getting answer as 25.6. But they have given a C as right answer, sir. 30% is right
They
answer,
have
sir.
given porosity, not void ratio.
Sir, I used porosity only, sir.
Okay.
Porosity I converted into E and then I used, sir.
Let me check.
But I am getting answer as 25.6, sir.
Let me check.
Okay, sir.
N is equals to E by 1 plus C, which is 0.3 by 1 plus 0.3. Sorry. E is equals to N by 0.3 by 0.7. So 0.3 by 0.7, which is going to be 0.428. E into SR is equals to W into G. Then SR is equals to 4.94% means 0.
Sir, sorry, sir. I made a mistake, sir. Sorry, sir. In simple calculation, instead of 0.7, I put 0.6, sir.
That's where you went wrong. Don't do these mistakes in examination because these type of mistakes I have done in the examination.
Okay, sir.
Okay, fine.
Sir, last doubt, sir.
Yeah, tell me, man.
In today's chapter, sir.
Yeah.
In results from triaxial test. In UU test, you gave the results, no, sir. Phi equal to 0, C equal to tau max.
Give me a minute.
Okay, sir.
Yeah, now tell me.
Yes, sir. In UU test results. Test results, UU, sir.
Yes, tell me.
Sir, you told C equal to sigma 1 minus C equal to tau max, you told, sir. Results, sir, from graph.
Okay. Yeah.
Yes. Sir. There, how C equal to sigma D by 2, sir?
What is sigma D?
Sigma D deviatrix, sir.
Well, you see over here. What is the sigma 1?
Sigma 1 is sigma D plus sigma C, sir.
Write down sigma 1 and sigma 3. What is sigma?
Sir, tell me again, sir. Repeat again, sir. Not hearing, sir.
What is sigma 1 minus sigma 3? You see this one, and what is sigma 1 minus sigma 3?
Sigma 1 minus sigma 3.
You see this?
Yes, sir.
Sigma C plus sigma D minus sigma C. Sigma C will get cancelled.
Okay, sir. What is
remaining?
Sigma D, sir.
That's it.
Okay, sir.
This means additional, right? Additional means the difference between the major and minor.
Okay, sir.
Yeah.
Thank you so much, sir.
Oh, okay, sir.
Okay, sir.
Mr. Sunny, you can speak out. Mr. Sunny, you can speak out.
Hello, sir. Are you audible, sir?
Yeah, you're audible to me. Tell me, Sunny.
It is previous gate question, sir, and stress distribution chapter, sir.
Okay.
Stress distribution, sir.
Previous gate question saying?
Yes, sir. Fourth question, sir. 2 marks, fourth question in stress distribution, sir. Page number 33 in gate question. Previous.
It's not responding. Give me a minute. I hope you are able to see now.
No, sir.
No, it's not visible to you.
Not visible to me, sir. But I have PDF, sir. I see the question, sir. Okay, sir.
I am showing the PDF now.
Yes, sir. Yes, sir.
Now, which chapter? Chapter number?
Stress distribution, sir. Chapter number 10. Chapter number 10, sir. 2 marks question, fourth.
2 marks question 4. What's the problem? They have given the pressure.
2008 gate question, sir.
Yeah, you have to convert. See, they have given you the pressure.
Yes, sir.
What is Q? Capital Q by area of. You need to find out capital Q first. What is capital Q?
Yes, sir.
150 into 2 into 1, which is going to be 300 kilonewtons. And assuming 2 vertical to 1 horizontal, then the delta sigma dash is nothing but Q by B plus Z into L plus Z. Yes. So at first you need to find the point load. Now at what depth they are asking? Z is equals to 1 meter, right? 300 by B value 1 plus 1 and L value 2 plus 1. So what is the answer? 50. What is the doubt you got?
He give answer 80, sir. 2 marks.
Who give answer?
No, sir, 50, sir. Sir, but I made a mistake, sir. I directly placed 150 instead of.
No, you have to convert that into point load.
No, sir. Sir, I made a mistake, sir. Thank you, sir.
Yeah, okay, man. Now, next, Aditya, Sai Krishna, Aditya, speak out.
Hello,
Yeah, Aditya, tell me.
sir. I have a doubt in sir previous ESC compaction chapter, sir.
Page number.
Sir, compaction chapter question number 13.
Page number. Page number.
Page number is 61. Yes, sir. Question number 13, sir.
What happened?
Sir, in this question, sir, they are using the line stabilization, no?
Yes.
Sir, line stabilization means the plasticity will be decreased.
Yes.
Means the consistency will increase, so strength will increase, sir.
Yes.
Sir, but dry density also will increase, no, sir, because we know that CI has more dry density than
Dry
CH.
density will increase.
Sir?
Dry density will increase.
Sir, answer they have given 2 only, means B option.
MDD and strength both will increase.
Yes, sir.
Okay. And MDD decreases, but the strength increases. No. MDD and OMC both increase.
No,
No.
OMC will decrease, sir. Yeah.
OMC will decrease. The answer is 1, right? Yeah.
Sir, answer is given B, sir, in 13.
Let me check.
Yeah.
Okay. See, this is a lime, right? This is not other soil, na?
Yes, sir.
Yeah. See, what happens to lime is the lime denseness is already less.
What, sir? Lime?
Lime denseness is already lesser.
Yes, sir. Yes, sir. Lime denseness is
So
less.
lime denseness is as lime denseness is already less than the clay, then the resultant denseness is going to be less. Okay.
Okay, sir. Means here we can't assess by compressibility factor.
Yeah. Listen one thing. If you add sand,
Yes, sir.
sand is a non-plastic soil which reduces the plasticity, and moreover, sand density is more than clay.
More. Yes, sir. Yes, sir.
Then MDD will increase.
Yes, sir.
But lime reduces the plasticity, but lime density is much lesser than the clay. So the resultant density is much lesser.
Okay, sir.
So when you add lime, then OMC will increase, MDD will decrease, and the strength is going to be increases.
Yes, sir. Okay.
Okay. So based upon that, the option 2 is going to be correct.
Yes, sir. Okay. Thank you, sir.
Okay. Please inform to the people to send the material as soon as possible. I have already informed that, and the ACE team is making sure all those things within a short period of time. So wait for that. Until that, you have a lot of resources to solve, right? So don't worry. Now next. today's caller. Next, my dear Damodar Rao. Raise your hand. Please speak out. Damodar.
Hi, sir.
Hi, Damodar.
Sir, I had a doubt regarding previous state consultation. Chapter 2 marks. 17th question.
Huh? 2 marks? Hello, Damodar.
2 marks, 17th.
Yeah. 17th question.
Consultation chapter.
What happened over there? Tell me, what happened? What's the problem with that? Hello? Hello? Okay, Mr. Damodar, as you are not able to hear, but I hope you can listen to my voice. So a layer of normally consolidated saturated thickness water subjected to one-dimensional consolidation under a pressure of 20 kilopascals, under a pressure increment of 20 kilopascals. So delta sigma dash is given as 20 kilopascals. Specific gravity 2.7, natural moisture content as 45%, compression index 0.45, decompression index 0.05. The initial average effective stress means initial overburden pressure is 100 kilopascals. Herzog is the primary consolidation settlement rounded to nearest mm. So what's the problem over there? The soil is going to be normally consolidated, they mentioned. What is the meaning of normally consolidation? Only compression, no recompression. Just simply SF is equals to Cc by 1 plus E naught into H into log base 10, 100 plus 20 by 100. That's it. You don't need to worry about this recompression index. Recompression index is for OCC, but the given soil is whom? NCC. So now the primary consolidation settlement they're asking. They have given the CC value how much? 0.45. Now you need to find out E naught. E naught is equals to SR1 W into G. So 0.45 into 2.7. 0.45 into 2.7, which is going to be 1.125. So 0.45 by 1 plus 1.125 into H value 1 into log base 10, 120 by 100. So you please solve this one. Log of 120 by 100. So into 1 into 0.45 by 2.215, which is going to be 0.0160 meters. Answer is going to be 16 mm now. Answer is 16 mm. So I hope if you have hearing this, I hope you understood this point. So that's it. You can solve this one. So that's not a big deal. Now let's go for the next. Vardhan, Mr. Vardhan, please speak out. Mr. Vardhan, please.
Good morning, sir. Good morning, sir. Hello.
Mr. Vardhan, I'm not able to hear your voice, Mr. Vardhan.
Good morning, sir.
Yeah, good afternoon. Tell me.
Previous gate PDF, sir.
Previous gate.
Page number 38.
Page number 38.
9th question.
Page number 38.
9th question, sir.
Question.
9th.
Okay, this one, linked type.
Yes, sir.
I have explained the same question yesterday also. So what's your doubt now?
దాంట్లో ఏవి సిసి టర్మ్స్ ముందే కనుక్కోవాలి సార్.
CC you have to find out, right?
సిసి కనుక్కొని మళ్ళీ అదే ఫార్ములా నుంచి ఈ నాట్ కనుక్కోవాలా సార్?
Yes, ante.
ఇది ఏవి నుంచి కూడా చేయొచ్చు.
ఎంత కనుక్కుంటావు చెప్పు ఇనిషియల్ వాయిడ్ రేషియో.
ఏవి డెల్టా ఈ బై డెల్టా సిగ్మా డాష్ సార్.
ఏవి అది కానీ ఏవి కాన్స్టెంటా?
ఏవి నో సార్.
అయితే ఏది కనుక్కోవాలి అప్పుడు?
సిసి.
దెన్
Thank you, sir.
Okay.
Mm.
Yeah. Sir, when do we calculate total plastic settlement due to compression and recompression? Can you please give example? I have given already examples. Mr. Amit, you please go through that. If the soil is OCC, then you have to go for recompression. If the soil is NCC, you have to go for the compression. Please go to the notes. Sir, can we manufacture sand? Yes, we can manufacture, but that is going to be different sand, not the sand we use in the case of construction. Now, today's last call, Mr. Venkatesh, please speak out. Mr. Venkatesh.
Sir, good afternoon, sir.
Good afternoon, Venkatesh. Tell me.
I have small doubt in capillarity concept, sir.
Capillarity, you tell me. What's the doubt?
Capillarity, change in pore water pressure is 0 at any depth, yes, sir.
What?
Below water table, change in pore water pressure equal to 0, na, sir.
Below water table, the change in pore water pressure is 0 due to capillary. Okay.
Yes, sir. How, sir, that?
You please go through that capillary notes. I have given you one question. See, the capillary rise is above the water table or below the water table?
Above the water.
That's it. The capillary effect will be seen in the pore water above the water table, not below the water table, right?
Okay.
So below the water table, if there is a capillarity or no capillarity, pore pressure is same.
Yes, sir.
Yeah, that's it.
Okay, sir. Thanks.
Yeah, okay, fine. Please explain previous gate consolidation chapter 250 question. Okay. This 15th question. What's the problem? They have given the details, right? From the given details, you can find out. First, you need to find out the vibration saturated unit weight. Then you apply. You can find out the SF. SF you can find out, Nana. So don't worry. Previous gate, 11th chapter, 9th question. Previous gate, 11th chapter, 9th question. Are in 11th chapter, is it 2 marks question or 1 mark question, my dear? Okay, so already I have explained this 9th question just now, so you please go through that and you can find out. 1 mark question already I explained, Re Baba. Previous gate 9th question I have already explained. You please go through the notes before asking the question. Go through the notes. I have already explained that one, so I'm not going to discuss it today. So it's already 1:45 now. I'm leaving. So question number 25 and 26, chapter number consolidation for ESC. So ESC. Have a nice day, Amit. And in notes, I didn't understand. Please go through that once again, Anna. That's my dear Anonymous. That curve is for OCC, not for NCC. So please explain question number 25 and 65 in consolidation chapter for ESC. This is the last question I'm going to discuss for today. So now the person who has asked me 25 question. So now you see here in the question number 25, theory of consolidation predicts settlement due to primary consolidation. Yes. It cannot include settlement due to initial compression, not due to secondary. Yes. This happens because of the following assumptions. Soil, grains and water are incompressible. Soil is fully saturated. Compression takes place in vertical direction only. Time lag in consolidation is entirely due to low permeability of the soil mass. It's not only due to the low permeability of the soil mass. See here the answer is going to be 4. 1, 2, 3 and 4 it should be there. Answer is going to be 1, 2, 3, 4. And I understood your next question. Question number 65, the same data. They have given 1, 2, 3, 4. Here all the options are correct. All options are correct. but the given data is not suitable. So the given data is not going to be suitable. When the given data is not going to be suitable, then you have to go for 1, 2, 3. But the answer is going to be all options are correct. Thank you for making geotech easy for me, sir. I'm really thankful for that, because what I want at the end of the day is to make sure the geotech is easy for you people. That's, I try my level best. Okay, so we'll discuss the remaining topics tomorrow. Have a nice day for all of you.